Hi folks, welcome back. So we need to start with $1 million question. What is AI, right? Now we are looking to go deep dive into the certifications for artificial intelligence, but what if we actually don't understand what is AI? How should we really go and start learning these concepts? So that's why it's very important you understand what is AI. So it's always good to break your words. So let's break the words artificial intelligence in and see the meanings, right? First of all, what is artificial, right? Artificial is something which is not natural, right? We talk about natural stuff, right? Which is present in the nature or it is naturally present, right? But when we talk about artificial, it is something that is man-made. So first of all, remember, artificial is something that the humans have made, right? Then we talk about intelligence, right? What is intelligence? Very, very simple word, but with a deep meaning. So intelligence is the ability to acquire and apply knowledge and skills. So if we combine these two terms, we are talking about artificial intelligence. So remember, it is man-made intelligence, right? It is not natural intelligence. Humans, they have got natural intelligence, but machines, computers, they have got artificial intelligence, right? And if I talk about the complete definition for AI, it is the ability or the capability of a computer system to mimic, right? To mimic means just like humans, right? You have human-like cognitive functions. Now you might ask, what is cognitive? So cognitive contains of mainly three things. So one is cognitive means knowing, then it means learning and understanding, right? So if we are looking to make the computers so smart that they have human-like cognitive functions, that the computers have understanding, they have the learning capabilities, and they have the knowing capabilities. So this is what combines as artificial intelligence, the ability or capability of computer system to mimic human-like cognitive functions. Okay, so in the next one, let's quickly take a look into the demo of AI. So I thought it would be good if I actually give you a quick demo on AI if you are like actually new to this field. What is AI? So let's quickly take a look.
Introducing Phantom, the most advanced chessboard in the world. We bring you the infinite possibilities of online chess with the engaging experience of a physical set. And Phantom is also the smartest board ever. It allows you to play against any other human on Earth remotely, or moving the pieces using only your voice.
Knight G4.
Play against our human-like AI, which continuously adapts to your playing level. The pieces become a sculpture that plays back the most famous games in history. Phantom, it's bringing back all the little details that make chess great.
Okay, so this was a perfect example of artificial intelligence, right? I'm not sure if you noticed, but there was a guy who just gave certain commands, and he was just simply using a speech. And in the world of AI, we call it NLP, or natural language processing, right? You're just simply saying, move to this, say G4, move the knight to G4, right? So, and just based on your command, the piece is moved, right? Then it also talks about that this is like a human-like AI, which adapts to your playing levels. So the computer or this chessboard is so intelligent that it can even adapt to your playing levels. It can understand whether you are an expert player or you are kind of a beginner, just based on the kind of moves you are making. First 10 moves or first 3 moves that you make, it can gauge that you are an expert player or you are in beginner level, and it will adapt its own playing levels against you, right? Perfect example of AI. Thanks for watching. So my dad always says that whenever you have to start with a new subject, always start with its history. So that's what I've done here. what I've done here is I've actually created a whole timeline of artificial intelligence for you guys. And you'll be surprised to see that artificial intelligence or AI has been available since ages, really. So we are talking about 1950s. So in 1950, there was a British mathematician called Alan Turing. He published a paper called Computing Machinery and Intelligence. So you can think about it that even in 1950s, they were thinking to make computers as intelligent as humans. And he also came up with a Turing test, which is quite a simple method of determining whether a machine can demonstrate human intelligence or not, right? So this was Turing test. Then we move on to 1956. In 1956, a guy known as John McCarthy coined the term artificial intelligence. So sometimes people ask, who is the father of artificial intelligence? So I always say the father of artificial intelligence is John McCarthy, because he was the one who coined the term artificial intelligence, and it was done at the first ever AI conference in Dartmouth College, right? So things started maturing in 1960s. Frank Rosenblatt builds the first Mark I perceptron, the first computer based on neural network, guys. So don't worry if you don't know about neural network. We will do deep dive into neural network in our upcoming lectures. But for the moment, you can think about it. A neural network is where the scientists thought, how does a brain work? So brain works on neurons. It's the same way they wanted to make machines intelligent and as intelligent as the human brain, right? But this was a very beginning of neural network, and hence it actually worked on trial and error, right? So it was just based on trial and error. So if you do something, if it errors out, then you improve upon your algorithm and go along. Then we move on to 1980s. So in 1980s, the neural networks were maturing enough, right? So if you see the neural networks which use backpropagation, so this was a new concept which came in. So there is always a concept of weights here within neurons. So these are all neurons, just like human brain, right? So there's a concept of backpropagation. So in machine learning, backpropagation is a gradient estimation method which is used to train the neural network. So it is basically a method which helps to train the neural network, right? So 1997, I even remember this when it was in news at that time, where IBM's Deep Blue beats the world chess champion. So at that time, Garry Kasparov was the world chess champion. So it was the first time that a computer was able to beat Garry Kasparov, and it was everywhere in the news at that time, because it was a big thing that a computer is that intelligent that it can even beat a world champion in chess. Right. Then things matured further in 2011. We're talking about Jeopardy. So Jeopardy is actually a game show. So rather than being given the question, the contestants are given general knowledge clues in the form of answers, and they must identify the person, place, thing, or the idea that the clue describes. And so phrasing each response in the form of a question. And this was the first time that IBM's Watson beats the champions Ken Jennings and Brad Rutter at Jeopardy. So if you see here, both the guys are there, and this guy is our IBM Watson, and he's able to easily beat these two champions. Right. Then we move on to 2015s. Things are maturing, guys. Things are heating up. So Baidu. So Baidu is a Chinese multinational technology company which specializes in internet-related services, products, and artificial intelligence. So in 2015, Baidu's Minhwa, so this was a Minhwa supercomputer which used special kind of deep neural network. So there is a concept of machine learning, there is a concept of deep learning. Don't worry at this stage, because we will learn about deep learning as well. It used to identify and categorize the images with high rate of accuracy than average human. So that was the beauty of it, that the results were much more accurate than as compared to the humans. Then we move on, 2016. So there was a board game called Go. So Go is an abstract strategy board game for two players, in which the aim is to capture more territory than the opponent by fencing off the empty space. So in 2016, DeepMind's AlphaGo program powered by, again, the deep neural network, beats Lee Sedol, the world champion of the Go game, in a 5-game match. So within 5 games, it was AlphaGo was able to defeat the champion at that time. So if you see, this is AlphaGo. It was able to defeat this guy, right? Now comes 2020s, guys. I always say this is a game changer in this whole. So AI was always there, but what changed the face of it is Gen AI. So you will hear a lot of these terms, generative AI. So OpenAI is a company which released GPT-3, which is world's sophisticated language processing AI model, which was capable of generating human-like text. Very important. So it is not predictive AI. We will learn again about the differences between predictive AI and generative AI, but for the moment, you can think about it that you are giving a prompt, or you're giving just a simple input, right? Write me a poem, write me an essay, write me a story, write me a letter. And the AI system is able to understand the context and create human-like text. That's why I say it is definitely game changer. And you will see from 2020s onwards, lot of things will happen in this space. And this space is where all the companies will be putting their research and development, their R&D budgets on generative AI. So I think with this, you've got a good understanding of the entire AI timeline. Hello and welcome. After taking a look into what is AI, the timelines of AI, it's time to take a look into the benefits of artificial intelligence. So why artificial intelligence is so important and why we are learning about this topic today, right? Just remember, guys, AI has been all around us, right? And it's been around us since ages, as we looked at the timelines. Now, if we talk about the benefits, the first one being no human error, right? Always remember, humans make mistakes. Now, if you talk about some major outages, right? Some of these outages have actually been related to a human error. Now here we are talking about smart, intelligent machines who do not make mistakes, because it's not a human who is performing a task, it's the computer that is actually performing the task. So no human error. Then 24/7 availability. Yes. So humans need to eat, drink, sleep to perform a task, right? But here we are talking about machines who can work 24/7 by 365. So all throughout your year, the machines can be working. They don't have to sleep, just like humans. So it's available 24/7. The third one, very important. So humans are sometimes biased. So bias means they are inclined, right? So they can be inclined to certain individuals, and sometimes they can be unfair as well. Very important. Humans can be biased. But here we are saying the machines are not biased. They are not making any emotional decisions, right? Because machines are going as per the algorithms, as per the models that they have been coded on, right? So they are unbiased decisions from a machine. And yes, machines can make quicker decision making. Why? Because, okay, human brain can process a lot of stuff, but machines can be really good in terms of parallel processing. So let's say you have to look into a lot of data, right? So humans, if they have to look at data manually, it can really take time to understand, to comprehend the data. But you give load of data to the machines and they can quickly make decisions out of that, right? And again, so we talk about there are less risks. Instead of no risks, I could say least risk or less risks, because again, you could even relate to the bias side of the things, because they are unbiased, right? So obviously there would be low risks. There is low risk in terms of no human errors, right? So because, as I said, humans make mistakes. So that's why you are mitigating, I should say, or reducing your risk levels, right? Because machines are performing the task here. And they've been very good with the healthcare applications. Now, AI is quite useful with sectors like finance, marketing, retail, but they have made a lot of development in the field of healthcare. So you can utilize AI for diagnosing diseases, predicting the outcomes, and it can go a level above, and it can even recommend the treatments as well. Very important, right? Another key point is managing recurring tasks, right? Now, another thing what I've seen in the industry is, if let's say you are a person, right, and every day you are asked to run a script, right? You are asked to run a script at 9 a.m. in the morning, right? Every day. If I ask you, I'm your manager, and I say, hey, just go and please execute this script every morning 9 a.m. That's it. That's your job. After some time, you will start saying, hey, it's a mundane task you've given me. I'm getting bored. I can't just keep on doing these. But that's the beauty of machines. They don't complain, right? You can keep on giving recurring tasks to the machine, to the computer, and the computer will be happily doing it for you. They won't complain. They are not emotional in that sense. Hey, I'm getting bored of doing this or running this script over and over again. So there can be a lot of benefits of AI, but here I've just showcased some of the key benefits of AI, which I thought should be there in your mind. Thanks for watching. So we've already taken a look at the fundamentals of AI. Now it's time to take a look at the various workloads. So we'll talk about what kind of workloads are we talking about when we are talking about artificial intelligence. So here we'll take a look. I'll explain you that workload, and what I've done is I've taken a very small kind of a demo or a video for you guys to get a very good understanding of that workload, right? The very first one is machine learning. Don't worry if you don't understand machine learning at this moment, because we'll do a deep dive into machine learning. What is machine learning? What are the types of machine learning? So for the moment, just try and understand that it is a branch of artificial intelligence and computer science, right, which focuses on the usage of data and algorithms to imitate or mimic the way humans learn and improve their accuracy. And the best example we give is of a cat and a dog, right? Just imagine when a child is born, is a child able to figure out whether it's a cat or a dog? No. So it's just based on learning, right? A child learns. A child will read books. The parents will tell him, okay, this is a cat. This is how a dog looks like. These are the features of a cat, and these are the features of a dog, right? Same way, what we are saying is machine learning. It is the way we teach a computer model to make predictions and draw conclusions from the data, right? Just like humans, just like a baby thinks like a cat and a dog, a machine or a computer is trained, and this training is done based on a computer model. So what I've done is I've taken a video of say Netflix. So Netflix is I would say the perfect example, because when you are watching movies, and if you have to watch a new movie, you will see that Netflix gives some recommendations. There's a concept of recommendations in Netflix. And how that recommendations works, it works on machine learning, because it's trying to understand that, oh, you love more of, say, thriller movies, or you love more of rom-coms or romantic comedies. So it will start recommending those movies to you. So quick video on that.
Is trying different algorithms and letting our members tell us what sort of experience actually work out for them, so we can make sure that whatever choice we make is the one choice that improves joy for our member base.
Through the process of A/B testing, you learn what the next challenge.
Okay, so here they're just talking about A/B testing, which is again a form of machine learning the Netflix guys are using for doing the recommendations, right? The next one we talk about is computer vision, right? So computer vision is a type of artificial intelligence which enables the computers to identify and classify the objects in images or videos. Now, if you just imagine, till now, what has been happening is that you've been uploading a video, or you've been uploading, say, a photograph, but computers were not able to identify what are the different objects within those photographs or those videos. Now, with computer vision, the machines have the capability to interpret the world visually through cameras, videos, and images. Again, a quick, say, video on this. Okay, perfect. So you could really see, if you can see from here, a computer is able to identify each and every object here, right? If there was a ball somewhere over here, the computer would have identified there's a ball, right? These are all humans, right? So this is the capability that you are able to identify and classify the objects within a video or an image. Next very important one is NLPs, or the natural language processing, right? As the name suggests, natural language. How do the humans speak? Humans speak in their own language. Like I'm speaking right now in English. Somebody could speak in Hindi. Other person could speak in some other language, right? So now it is the capability within AI for a computer to interpret written or spoken language and then respond in kind. The perfect example of this is Alexa, right? So sorry, I had to switch off my Alexa because I'm sure when I said Alexa, it will wake up my Alexa. Right? So the thing is that, and I'll give you a quick example and a video on this as well.
Alexa, open Amazon Math.
Welcome to Amazon Math, a fun place where we can practice math together. Well done. Next question. You got 5 out of 5 correct.
Alexa, announce I finished homework.
Okay, so perfect example of NLP or natural language processing, right?
Is trying different algorithms.
Okay, now we will talk about Gen AI or generative AI. So guys, remember there is a shift from predictive AI to generative AI. Previously, there used to be predictive AI, right? So there was a predictive AI. Predictive AI, and here we are talking about Gen AI, right? The difference is clear. With predictive AI, we knew the outcome, or the computer was already told, hey, you need to tell me whether based on this data, whether this person is having diabetes or this person is not having diabetes. So I'm just feeding the data and it is giving me the results telling me, okay, this person A has diabetes, person B doesn't have diabetes. But here we are talking about Gen AI, right? Generative. You are generating on the fly, right? So it says it is a capability within AI to create original content. Very important, original content, right? Perfect example. Now, let's say you met your wife and you want to say surprise her on her birthday by writing a poem for her, right? And you'll just simply give certain kind of say inputs to Gen AI system, and you'll say, hey, I love my wife. I met her at this place, and these are her likings, and these are her positives, and it will just generate a nice poem for you. So that is perfect example of generative AI. So remember, it can be in different formats, including natural language, image, code, and more. So even you can ask it to write a code for you. Let's say you want a Python code to create a graph, right? So you can ask Gen AI to write a code for you, right? Or you can ask for an image. You can ask for an architectural diagram, how cybersecurity workflows look like, right? Again, an example of generative AI. So here again, I'm taking a quick example of, say, ChatGPT, which is like quite popular these days. Oracle is also coming up with its own flavor of Gen AI. But here, just to give a good understanding, we'll talk about the ChatGPT. So yeah, so here you can see it just simply said, write a 400-word review on gas sensor datasets, right? And within a matter of few seconds, it started generating the data for you. So, and it's in front of you. It's pretty quick. It's amazing the way it does, right? So it's a perfect example of Gen AI or generative AI. So I think with this, you've got a very good understanding of what are the various types of workloads in the field of AI or artificial intelligence. Okay, so another key question that is asked when you're studying AI or artificial intelligence is, what is the difference between artificial intelligence, machine learning, deep learning? So we call it as AI versus ML versus DL. Now, the best way to understand is to look at it in a way of an onion, right? So you can see that there are different layers of onions, right? And same way, what we have done here is we have shown artificial intelligence, machine learning, and deep learning. So if you talk about it, you can talk about that in the form of various layers, right? The topmost layer is artificial intelligence. Right. So now we all understand that AI is the capability of a computer system to mimic human-like cognitive functions. And now we know cognitive stands for knowing, learning, understanding, right? So this is the top level, artificial intelligence. So underneath AI comes ML, which is machine learning. Now, we understood that machine learning is nothing but it is a branch of AI and computer science which focuses on the use of data and algorithms to imitate or mimic the way humans learn and they improve the accuracy. And the best examples I gave you was that when a baby is born, the baby can't distinguish between a cat and a dog, right? So same way a baby learns, right? Based on the books that he or she reads, or the parents or the teachers, they tell the features of a cat and a dog. And another good example of machine learning we learned was Netflix, right? Netflix, how it gives you various recommendations on the movies that you should be watching. So machine learning is a subset of AI which uses statistical methods to enable machines to improve with experience. So the key here is improve, right? You are learning, you are improving, right? Then comes a field called deep learning or DL, right? So remember, deep learning is a method in artificial intelligence which teaches computers to process the data in a way that is inspired by human brain. Very important. It is inspired by human brain. That's why the concept of neural networks comes into picture. So it is a subset of ML or a subset of machine learning which makes the computation of multi-layer neural network feasible. We will do a more deep dive onto neural network. But for the moment, you try and understand that deep learning is a foundation for driverless cars, right? We talk about driverless cars. We talk about Gen AI systems, right? So at the back end or the backbone of deep learning I would say deep learning is actually the backbone for driverless cars or generative AI, right? Very important. So AI versus ML versus DL. It is a layered mechanism. Topmost layer AI, then underneath comes machine learning, then comes deep learning. So thanks for watching. Hi folks, welcome back. After getting a good understanding of the AI foundations or fundamentals, it's time to take a look into machine learning foundations. And machine learning is quite an important topic from your exam point of view as well, because if you look at your syllabus, there is a 30% weightage on machine learning and deep learning, right? And if we go deep dive into what are the various topics, you can see that for machine learning, I've highlighted the key topics. You need to understand the key concepts and terminologies of machine learning. Very important. What exactly is machine learning And there are a lot of key terminologies for machine learning, like what is an algorithm, what is a model, right? So these are very specific things. When you talk to somebody in the field of AI, they will be speaking about these terms. But if you don't have the foundations or fundamentals of that specific terminologies, you would really struggle in this field, right? The next type is, it says you need to have a good understanding of the common machine learning types, right? So now there are different types of machine learning. It could be supervised machine learning, which has classification, which has got regression. Then you have unsupervised machine learning, which has got clustering, and there's a third type of machine learning, which is called the reinforcement machine learning. So don't worry, we'll delve into these topics one by one and give you a good understanding of machine learning. Now in the next video, what I want you to do is I want to give you a real world use case of machine learning. Before I actually start giving you definitions and before we start going into the theory, why not look at a real use case of machine learning? And yes, our favorite, Netflix. Thanks for watching. Okay, so let's take a look at a real world example of machine learning. So it's just people who are actually working on machine learning in Netflix day in, day out, and they'd be sharing their experiences. So for the moment, just try to have a look. Don't worry, we'll be going into the theoretical part of machine learning just after this video.
At Netflix, we have over 120 million members. They span the whole globe across 190 different countries, as well as a diversity of titles, content, comedies, and dramas. Machine learning is deeply intertwined with all aspects of Netflix's business. How we compose our catalog of content, how we produce our content, how we encode it, how we stream it. We use machine learning to help marketing efforts and advertising efforts. And then we also use machine learning in our content acquisition effort.
Okay, so this was just a quick snippet or a video on machine learning in real world. So in the next video, we'll start learning about some of the key terminologies of machine learning. Because once you get a good understanding of the key terminologies, then you can have a good hold of the machine learning fundamentals. Thanks for watching. Hi folks, welcome back. So now it's time to go into the theoretical definitions and the different terminologies for machine learning, right? So before we actually go more deep dive into machine learning, what I thought was, won't it be better to actually give you guys a good understanding of different terminologies? It's very important because whenever you are reading about machine learning, artificial intelligence, or when you're talking to AI professionals, data scientists, these are the kind of words they will keep on saying. And if you don't have a good understanding of these words or terminologies, you'll really struggle in the field of machine learning or AI. So let's take a look what these are. Very fundamental concepts, right? The very first one is an algorithm, right? What is an algorithm? Now, if I ask you a general definition of algorithm, when we used to study maths or even physics, what was algorithm? So algorithm is always refers to a set of rules. And in machine learning, an algorithm refers to a set of rules and statistical techniques, right? Now, you might remember, but what is statistics? So a clear definition of statistics is nothing but study and manipulation of data, including the ways to gather, review, analyze and draw conclusions from data, right? So it's nothing but you have a lot of data, and from that data you need to draw some conclusions, right? So that is the branch of mathematics which is called statistics. So algorithm is a set of rules and statistical techniques. Now here we take a good example of this. There is a decision tree algorithm, right? Now a perfect example of that is Gmail, right? When Gmail came, So when Gmail came, it never had a concept of filters, right? After some time, they came up with the concept of filters where they used to put spam or not spam, right? What are they doing? They are looking at your data, they are looking at your emails, and based on certain set of rules, they are telling you that, oh, this email seems to be a spam email and this email seems to be a say not spam email. And how are they doing it? They're doing it based on the features, right? Now in machine learning world, we call them features, right? Or you could even say artifacts, right? But it could be features like who is the email sender. Now there could be certain blocked set of senders in the list of Gmail. If they look at it, if the person who's sending is out of that block list, they can easily tell. They can also tell about the frequency of certain words. It could be like, hey, you have won a lottery, or there is money in your account, right? So these are the kind of things which are luring you to actually click on certain links. They can easily make out that it's just spam or not spam, right? So this is your algorithm. Next comes the concept of a model, right? Again, model is what an algorithm creates. So always remember, a model is derived from an algorithm, right? So a model is derived from an algorithm. So a model is what an algorithm creates, right? After being trained on the data. We'll look at training as well, but for the moment, just try to understand that a model is coming from an algorithm, right? So it is essentially the learned representation of data. Another way to say a model is it's a learned representation of data. If I keep on feeding the data, then based on that, I can easily learn from that data, right? And then the program that can find the patterns to make the decisions. So think of it like a Python program, right? We will see in more details as well. So a model could be, you can say it's a Python program which can find the patterns for making decisions, right? Now, algorithm was a set of rules based on statistical techniques. Model is something which is derived from the algorithm, right? And here we give an example of a data set of house features, right? And the prices to a regression algorithm. The model it creates can predict price of new houses based on the feature. So let's say if I feed a lot of data, right? If I'm feeding that, okay, if the elevation of the house is this much and the features of the house is this much, what could be the price of the house, right? So if we feed that kind of data, if I feed new data, then based on my model, it can easily predict, hey, your house can fall in the range of say 100,000 to 200,000 or 200,000 to a million, right? So it goes like that. So model is an algorithm. Is what an algorithm creates after being trained on the data. Please remember that. And it's a program that can help you find patterns to make decisions. Right, now comes the concept of training, right? So you always train your model. Remember, you are training your model, right? Like the way you are training your baby to make decisions or your child to make decisions, same way you're training your model. So this is the process of presenting the data to machine learning algorithms. So what are you doing in training? You are getting a lot of data and you're giving it to the machine learning algorithm to create a model, right? So you take the data, you train, and then you create a model. And then you create a model. So you take the data, you train the data, and then you create a model. So presenting data to a machine learning algorithm to create a model. Right, the algorithm uses training data to learn. So always remember this algorithm depends on the training data to actually learn from it. And another example, good example of it is a neural network. So let's say if I show thousands of pictures of cats and dogs to the training model, it can help me identify which is a cat and which is a dog. Just based on the features, it can tell me If I just add, okay, the ears are like this, the eyes are like this, and if I give you a few more features, then the neural network would be able to tell me whether based on this, is it a cat or is it a dog? Very important. So training, you are training, which is the process of presenting the data to machine learning algorithm, which creates a model. Then there's a concept of labels. Again, label is nothing but this is the output you want the model to predict. Very simple. It's just a key terminology for machine learning. If somebody asks you what are the labels, labels is nothing but he or she is asking you about the output, right? What is the output? And here we take an example of a tumor. Say you want to see whether the label is, the label might be whether the tumor is malignant or benign. Malignant means whether the tumor is really dangerous, or benign means that it's fine. It's not a major issue, right? So just take an example from the healthcare. So yeah, I think with this we come to the end of machine learning key terminologies. Remember, algorithm, set of rules. Model is what an algorithm creates after being trained on the data. Training is a process of presenting a lot of data to machine learning algorithm to create a model, right? So you train the data and you create the model. Then labels are nothing but the output. So thanks for watching. Hello and welcome. So time has finally come to talk about machine learning. Now, before we try and go into the details of what is machine learning, I would say we should get an understanding of how do humans learn. So just think about it. Let's say when a baby is born, do you think a baby is able to distinguish between a cat, a dog, and a horse? No. How would a baby learn? So the baby will learn through a process where a baby will try to identify based on different features, right? So it can think of it like if it is having a long ear, black nose, then it could be a dog, right? If the eyes are specifically blue in color, then, and it's very small, then it could be a cat, right? So how are you learning, or how is a human learning? A human is just learning by examples. We normally say you could easily learn by examples, what you see all around. Then you could even see diagrams, or you can make some comparisons, right? So the same way a human or a baby is learning, same way we are making a machine to learn, right? Now you might ask, but how do you do that? So how would you do that? If I give you an example, now here, if I feed, say, thousands of photographs of dog, cat, horse, and probably then label them as well, that if you have this kind of a feature, if your ear length is this, if your nose is like this, if your eyes are like this, then you are a cat. Otherwise, you are a dog or you're a horse. So I'm feeding, let's say, a lot of data to the computer. And based on that, I'm trying to identify the patterns out of it. And once I have identified the patterns, then I will train my algorithm. And once my model is ready, based on that algorithm, then any new data that comes in, it can make predictions for me, right? It can tell me based on these features, whether it's a cat, it's a dog, it's a horse, right? So theoretically, so machine learning is a branch of artificial intelligence. Now you might remember we discussed about the onion thing, right? The AI, ML, DL, right? So AI, ML, and DL. So ML or machine learning is a subset of artificial intelligence. Now this subset focuses on the usage of data and algorithms. Very important. Guys, if you ask me, what is the heart and soul of machine learning? I would say the heart and soul of machine learning is data. Very important. Your data needs is very important here, right? And you are focusing on the usage of data and algorithms. Now we learned about algorithms. Algorithms are nothing but set of rules, right? Normally based on, say, statistical mathematical techniques as well. Now machine learning is helping a machine to imitate or mimic the way that humans learn, gradually improving its accuracy, right? Perfect. As I told you, how would a baby or how would a human learn? You would look at examples and you will gradually improve your accuracy, right? So when you look at different examples, when you do comparisons, then you would be able to make out that yes, it is a cat, it is a dog, or a horse. So in machine learning, computers apply statistical learning techniques to automatically identify patterns in data. Very important. As I told you, statistics is nothing but it's the study and manipulation of data, including ways to gather, review, analyze, and draw conclusions out of your data. Right? That's very important. And if you try and see this diagram, it clearly says that you have data and data contains patterns. Now, your algorithm is such that you need to find the patterns in the data, right? Let's say if I talk about the cat and dog example, there will be features, different features, right? You need to identify the patterns in those features. And you will actually train your algorithm based on this data, right? So once you've trained your algorithm, then you build a model. Very important. Once you have built your model, then any new data that comes in will be fed through that model, right? So this is normally, you can say this could be your, training data. So data is always divided into training data, and you can say it's more of like a testing data or test data, which will help to check the accuracy of that model. Don't worry, we'll actually talk about a more workflow of machine learning, in that you will see in more details. But for the moment, just understand data has got patterns. We are trying to find those patterns. We are trying to train our algorithm, right, using the training data. And once you have trained your algorithm, then you build a model out of it, right? And that model helps you anyways recognize patterns in the data. And once you have built a model, right, then you use new data. So you won't use the training data again. You will use testing data, which is separate. So testing data is fed into the model to give you predictions and descriptions. So let's say if I give few features, then it should be able to tell me that whether it is a cat, it is a dog, or it's a horse, right? That's what is the aim of machine learning. So as I said, these patterns are then used to create a data model that can make predictions, right? And with increased data and experience, the result of machine learning are more accurate. So as we said, how humans learn? Humans learn gradually, right? They improve upon their accuracy. Same way machine learning algorithms improve, right? Whatever say patterns it is finding out, you use the testing data and you improve upon your parameters, and you actually learn as you go along, right? And yes, there are three main approaches, and don't worry, we'll actually go deep dive into all of these. One is called the supervised learning, which is the learning from labeled data. So this example is a labeled data because I'm giving the features and I'm also telling if this is the feature, then it's a cat. If this is a feature, then it's a dog. So it's a kind of a labeled data. Then we have unsupervised learning. So supervised is where you are actually labeling your data. Unsupervised is where you don't have the labeled data and you have the unlabeled data. Very important. And unsupervised learning helps to identify patterns and structured in the unlabeled data. And we have another type which is called the reinforcement learning. So you keep on learning. We say that it is learning based on rewards or penalties. Again, I always give an example of a baby, right? A baby or a student, right? How do the teachers do? The teachers will always give you rewards if you do something good, but they'll also give you penalties, right? If you don't do something wrong, if you do something wrong, or if you're not on the right track. Same way, we are training our baby, we are training our machine, and this is based on reinforcement learning. Again, we'll go more deep dive into this. Don't worry about it. Very, 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 very important point. I always talk about the heart and soul of machine learning is data. Now, you might say data is fine, but two key factors in data, the quality and the quantity. So it heavily relies on data quality, because if you are giving garbage, if I'm giving garbage data here, I should expect my model to be garbage. As simple as that, right? So we need to spend some time doing data pre-processing. Very important. So data quality is very important. Again, the data quantity is important. You will see that your model or the accuracy of model will improve. Let's say if I have, let's say, 100 things I'm feeding into this, and if I'm actually feeding 10,000, then you will obviously see that my model improves, right? So the data quantity is also important, right? Again, based on the example of cat and dog, if I'm feeding in, let's say, 100 rows, right? My model is getting trained, but I'm feeding 10,000 rows, then it's really getting a good understanding of patterns. This is the key here. You are trying to understand the patterns here, and based on that, you can make predictions. And algorithms, as we already saw in previous lecture, algorithm is nothing but the set of rules, and they are normally based on the statistical mathematical techniques. Utilizes a variety of algorithms tailored to specific type of data and learning tasks. And yes, as we saw an example of machine learning in, say, Netflix, I already showed you, it is actually being applied in diverse fields. You can use machine learning in healthcare industry, in finance, especially if you have to do, say, fraud detection. Then it is being used for autonomous vehicles and also for tasks like prediction, classification, clustering, and deployment. So the trained models, like if I take example of this, let's say this is my trained model, right? Once my model is built, this is my trained models are deployed in real world applications to provide insights, automate the tasks, or even enhancing the decision making. So I think by now you've got a very good understanding of what is machine learning. So always remember that whenever somebody asks you machine learning, just think about the way humans learn. Or a baby, once a baby is born, how would the baby get trained? Same way we are training our machine, we are training our computer program based on the data we are getting. And very important points, data-centric machine learning heavily relies on quality of data and quantity of data. Thanks for watching. Okay, so now we have got a very good understanding of what is machine learning. We saw some examples of machine learning. Then we also discussed the workflow of machine learning. Now it's important to understand what are the various types of machine learning algorithms. And guys, we'll do a deep dive into each of these, right? So we will learn about supervised machine learning. Supervised machine learning is where the model training is done based on the labeled data. Don't worry, we'll do a deep dive. We'll try and understand what is classification, what is regression, right? Then we will talk about unsupervised learning. And we will also understand why is a supervised learning called supervised. Why unsupervised is called unsupervised. Because it is using unlabeled data, but I'll give you more details when we come to that video. With unsupervised learning, we have a concept of clustering, right? And each of these models or each of these, algorithms have their different use case that they address, and we will discuss about those use cases as well. Then comes reinforcement learning. As I told you previously, reinforcement learning always works on the reward and punishment method, right? As we said, like a baby learns, you give a baby some reward, or your student some reward, or you give some punishment, right? So it works like that. That's why it's called a reinforcement learning, which so the model takes actions in the environment, then received state updates and feedback. So it is always based on the feedback loop, right? So with this quick video, I just wanted to showcase that there are mainly three types of machine learning algorithms we'll be learning: supervised, unsupervised, reinforcement. With supervised, we have classification, regression; unsupervised, mainly clustering; and then we have reinforcement learning. So in the next video, we'll talk about supervised learning. See you in the video. Thanks for watching. Hello and welcome. It's time to take a look into supervised machine learning. So guys, whenever I pick a new subject, I always look at its root word, right? So here we are learning supervised machine learning. So what is the root word here? If you ask me, the root word here is supervisor, right? So now you might ask, who is a supervisor? So supervisor is a person who is in charge of a group and who makes sure that the work is done correctly, accurately, and as per the rules. So that is a supervisor. Now, somebody who's coined this term supervised machine learning, why are they calling it as supervised? Why it is called supervised? Because it is based on the labeled data set. Now, that's the beauty of supervised machine learning, because you are labeling your data set, right? Like we took the example of cat and a dog, where we said you are giving a feature, you are giving, let's say, 3 features: type of nose, type of ears, length of the ears, and then you are labeling it's a cat, it's a dog, right? So a labeled data set is a data set where data is clearly annotated with meaningful tags or labels that classify the outcome. So you already know the outcome, right? And these data sets are designed to train or supervise the algorithm. So if somebody asks you who is the supervisor here, you will say the labeled data set is the supervisor. Labeled data set is the supervisor, right? So let's take a look. So the supervised learning involves training a model on a data set that includes both input data and corresponding correct output. Now here we'll take an example of the iris flower, right? Iris is a flower, and here what we are doing is we are actually, and there are different types of iris, right? Or the various varieties of iris. It could be a setosa, it could be a versicolor, or it could be a virginica, right? So as part of that, and all these would differ based on the features, like what is the sepal length, sepal width, petal length. You can identify whether which class of the iris flower does it belong to. And first of all, sepal is nothing but the outer part of the flower, which is normally like the green part, right? That is your sepal, and petals we all know, right? So what I want to make sure, or what I want to tell you, is that this is the kind of an input you are giving, but you already are giving the output as well, right? You are labeling your data. So that's why it says it's a data set that includes both input data. What is my input data? Input data is sepal length, sepal width, petal length, petal width, and the corresponding output. The corresponding output is whether it is a setosa, whether it's a versicolor. So the aim is that if I'm giving thousands of data, thousands of rows to my model based on these features, it can come to know, okay, if this is the length, width, petal, then it should fall under which categories. Again, we are talking about finding the patterns in data to give the right prediction of the data, right? Okay, so as I said, it's a labeled data. The training data set must be labeled, meaning each example is paired with correct answer. Very, very true. As you can see, we are giving all the length, width of petal and sepal, and we are also giving the the correct answer, like what class it belongs to. Okay, and there are different algorithm types in supervised machine learning. You could talk about linear regression, logistic regression, SVMs like support vector machines, decision trees are there, neural networks are there, which you'll actually study in deep learning as well. Okay, so the training process is pretty simple. What we just learned in the machine learning workflow, the model learns a function that maps the input to desired output and makes prediction based on that function. So it's pretty simple, right? You are learning based on the training data. You are able to identify the patterns, and then you can make predictions. As simple as that. Just think about it. Let's say I feed this data, right? If I feed this data, which is new data, and to the computer or to my model, if I give 5.9, 3.0, 5.0, 1.8, the model should be that accurate that it should be able to tell me, hey, based on this input data, it is a virginica. That's what is the aim of this, right? Yes, and the supervised machine learning normally has a risk, and risk is of overfitting. Overfitting is nothing but we are just saying that it can give you inaccurate results, right? The results are not accurate if the unseen data is given to it. So one way is that you something that the computer already knows of, that's fine. But what if you give some unseen data to it? Obviously you won't get the accuracy with that. So supervised machine learning models can overfit the training data, meaning they may not perform well on new or unseen data, right? So with training data, everything is going well, your model is performing, but suddenly some unseen data comes up which the model is not aware of, and it can give you inaccurate results, right? So what are the applications? Now you might say it can be used in various applications like image recognition, right? We did the example of a cat and a dog. Like if I'm giving a lot of images, the computer is able to identify which is a cat, which is a dog, right? And same way, speech recognition. A lot of say banks are using speech recognition software these days. So normally with HSBC, I've seen that they say that my voice is my password. So if I say that, it is able to recognize that my voice is actually my password. So if somebody else tries to say these lines, the computer will identify that it is not this person, but some other person trying to enter the account, right? Same way it is used in medical diagnosis. Spam detection, we already saw the use case, which was where we talk about whether it's a spam or a not spam email, which is like a ham, and it also used in a stock price prediction as well. So with supervised machine learning, we have two types, which is classification, which is used for sorting items into different categories. As you can see, we are sorting. Or there is regression, which is identifying the real values, which is talks about the continuous values, right? So don't worry, we'll take a look into the types of supervised machine learning in the next videos. What is classification? What is regression? Thanks for watching. So there are two types of machine learning or supervised machine learning per se. And we said that one is classification and other is regression. Right now, as I always say, always look at the root word, right? So what is the root word in classification? The root word in classification is classify, right? Now you may ask, what does classify mean? So classify means to arrange a group of people or things in classes or categories. It's as simple as that. All you are doing is you have got a lot of things and you are just grouping them. Like if I take a perfect example, here you can say I have a brinjal, I have a broccoli, I have a carrot, right? I have some burgers and all, right? So you want to categorize them. So we just pass this through the classification model or a machine learning model, and it is able to classify that, okay, all these fall under the category of vegetables and this falls under the category of groceries, right? So just think about it. If a company wants to do some analytics and they want to see how much stuff the customers are buying, and they want to categorize how much vegetables people are buying, how much groceries they are buying. So this is what we call classification. Okay, so if we go with the definition of it, a classification involves assigning category labels to the new observations based on the past observations and labels. Now remember, as I told you, that you have got labeled data, right? This is a labeled data. That's why we are learning supervised machine learning. But the aim of supervised machine learning classification is to assign category labels. And anyways, you know about those category labels when we are actually, say, inputting your data, right? The classification can be binary. Binary, as we know, 0, 1s. So we are talking about two classes. Like here, you can say whether an email is spam or it's a ham. So not spam is also known as ham. And this is a perfect example. Let's say a lot of emails are being fed to the classifier. Now this classifier, based on its features, its machine learning algorithm is able to identify which one is a ham and which one is a spam, right? And based on that, it will send either to the inbox or it would send it to the spam folder. So simple. Either you can have binary, 2 classes, or you can go with multi-class as well. Multi-class could be that I'm trying to classify the types of fruits. So there could be multiple types of fruits and I'm just classifying based on that, right? So the common algorithms that we deploy with machine learning classification are decision tree, random forests, logistic regression, support vector machines, and neural networks. So don't worry about it, just the names that you should be aware of. And feature selection, right? So choosing the right features or inputs is critical for building an effective classification model. So it's very important that you know the features, right? So based on the features, only you would be able to identify or classify a model. It's a very good example here. We have taken about machine learning used in the healthcare sector. Like if you have to detect for the prostate cancer, right, you would be feeding a lot of images, right? And when it goes via the feature design, the MRI prostate image does contain a lesion or it doesn't contain a lesion. So lesion means whether that area is damaged or it is having injury, or it could be something like it's having cancer, right? So all we are saying it is passed by the feature design, and based on that, it is able to identify or classify whether this category, this falls in the prostate cancer category or it falls under a different category, right? So just imagine if a person had to look at those images. Now a machine is looking into those thousands of images and giving the results, right? So choosing the right features is critical for building an effective classification model. So because here we are talking about healthcare sector, if you're not going with the right features, then maybe you could miss something. A person having cancer, and you might say, oh, it doesn't have cancer. So you need to be very careful in choosing your features. And yes, this is a supervised machine learning. So we are using labeled data. Remember, as we did with Setosa flower, it is a labeled data that you are giving. So it requires a labeled data set where each instance is tagged with correct class for training, right? So here, when you're feeding the data, you're already telling whether this belongs to this category or not. And this is your training data. And when the test data comes, just based on the test data, the machine learning algorithm should be able to identify in which category does it fall, right? Perfect. So then we talk about overfitting and underfitting. So what is overfitting? So we normally call it's an undesirable machine learning behavior, and it can occur when the machine learning model gives accurate predictions, because your aim is getting accurate predictions, but this happens only for training data and not for the new data, right? Or the test data. So that's why we call it overfitting. So balancing the complexity of the model to prevent overfitting or underfitting is very important. So what it says is that your model you really need to tweak your model. So this is where testing comes into picture. So based on this, you need to balance the overfitting and underfitting as well, right? So how the model performs with the the testing data should be similar to how it performs with the training data. Okay, so now there are various applications as we discussed. Email spam detection is one of them. Then image recognition, as you can see, this is a perfect example of image recognition. So I am, let's say, feeding in a lot of images, MRI prostate images, and based on that it's able to detect whether it's cancer or not. Medical diagnosis, as we discussed, and sentiment analysis as well. And it's even quite useful in real-time decision making, and in banking it can be used with fraud detection. So let's say there is a transaction A, transaction B, and based on, or there are multiple transactions, then based on the behavior or the features, it's able to identify whether I should put it in a fraud category or I should put in a normal category. Again, a good example of machine learning using classification. So with this, we come to the end of the lecture. Remember, what we learned in this lecture is supervised machine learning classification. Very simple. You are just classifying, or you are just adding category labels. Classify, as I said, arranging a group of people or things in classes or categories. Thanks for watching. Hi folks, welcome back. So in the previous video, we saw what is supervised machine learning classification. Now we will talk about regression. Now again, you might ask, but what is regression, right? Regression is nothing but a statistical technique that relates a dependent variable to an independent variable. Now you might ask, but hey, what is dependent variable? What is independent variable? This is all very confusing. I'll take a very simple example. If you say y is equal to 2x, right? We all would have learned this sometime in algebra during our childhood days, like y is 2x plus 1 or something. For the moment, I'll just say y is equal to 2x, right? So here x is an independent variable, right? So this is an independent variable and y is a dependent variable. Now you might ask, but why is y dependent variable? Yes, because the value of y will change as I change the value of x, right? So if I put x as 2, then y becomes 4. If I put x as, say, x is 2, and if I put x as 3, then it becomes 6. As simple as that, right? So if the value of x is 3, then the value of y becomes 6. So it means my y is actually the independent variable. And remember, the independent variable always goes on the x-axis and the dependent variable goes on the y-axis. And normally you would always plot the graph, something like a scatter graph we call it, and you can see and these are all the different data points, right? So let's take a look. What is regression analysis? So regression analysis predicts a continuous output, right? Dependent variable. So you are continuously trying to find out your dependent variable. You're continuously trying to find out the value of y based on one or more predictor, which is the independent variable, right? Pretty simple, right? Now, again, if I take an example of house price prediction, right? So here, if you see, what it is saying is that normally the case is that if the size of the house increasing, the price of the house will increase. So just imagine that if there is a house which is somewhere around 2500 square foot, right? So obviously its price would be quite high, somewhere in this range, right? So this is how we are basically predicting. Like if let's say you bring your test data where the house size is somewhere in the range of 1250, then you should be able to figure out what is my dependent variable. So you'll try to figure out, oh, this the cost of the house might stay somewhere between 200 and 300, maybe around 220. So you are just predicting. This is just prediction. This is not actual, right? Remember, this is just prediction. Perfect. So linear regression. Now again, with this, there are two forms. One is linear regression and there is multiple regression. So first we talk about linear regression. Linear, it's a simplest form of regression and it assumes a linear relationship. So linear relationship means that you are having an input variable and you are having an output variable. And here we have taken an example of linear regression, which is predicting the house price based on the size. So per square feet size, and you're trying to get the size of the price of the house, right? This is linear regression, simplest. Then we talk about multiple regression. Now remember, in linear regression you have only one independent variable, right? But in multiple regression it involves two or more independent variables, right? And so let's say you have to predict the car price based on the features like age, mileage, brand, engine size. So there are a lot of other features that are being added to it. So that's why we call it multiple regression, right? Which involves two or more independent variables. Then we talk about line of regression. So here, if you see, this is what we call the line of regression. This is the line of regression, and this line of regression can be used to predict the value of y for a given value of x. So whatever algorithm you are using, I just gave you a simple example like y equal to 2x, but remember, this regression line or line of regression helps to predict the value of y for a given value of x. Now you might ask, okay, but what are the applications? So widely used in finance, in stock price prediction, you can you can do some predictions on what your stock price would be based on the historical data. Then it can be used in medical diagnosis and forecasting sales in retail based on the historical data and market trends. And yes, as I said, overfitting is an undesirable machine learning behavior which can occur when you don't get accurate predictions for the test data, but you do get it for the training data, right? So quite important that you need to get a balance right. So you need to ensure that the model fits the training data as well as the unseen data or the testing data. And the example it gives is that there is a complex model, right? And the complex model might fit the training data on stock market prices, but fails to predict future prices accurately, right? So again, as I said, it works well on the the training data. When you're doing the training and all, it looks all hunky-dory, very nice. But as soon as you try to bring unseen data, new data, then it starts to fail. This is where you need to tweak your model a bit, right? So remember, this is what we call overfitting problem and underfitting problem, and most of the machine learning algorithms always suffer from this. So you need to tweak or tune your models accordingly, right? And here what I've done is just given a quick example between or difference between regression and classification, just in case you are getting confused. Will it be hot or will it be cold tomorrow? So you are categorizing whether it will be hot, whether it will be cold, right? So you are saying, okay, and based on the data you are getting, you are saying it will be hot or cold. This is classification. Regression, as we said, it predicts a continuous output. So what will be the temperature tomorrow, right? Weather forecasting. You're doing weather forecasting here, and every day or on a continuous basis, you are doing this weather forecasting. That's why we call it regression. So remember, regression analysis predicts a continuous output. You get the value of dependent variable based on one or more independent variables. Thanks for watching. So after having a good understanding of what is supervised machine learning, it's now time to take a look into unsupervised machine learning, right? And remember, with unsupervised machine learning, there are mainly two types of machine learning we talk about. We talk about clustering and we talk about association. So let's take a look. Okay, first of all, you need to remember the golden rule here. The golden rule is that with supervised machine learning, you always work on labeled data, right? As I told you, you are, let's say, inserting a lot of pictures of cats and dogs, right? But when you are inserting those pictures, you are labeling your output that this is a cat, this is a dog. And this is why it is called supervised machine learning, because your labeled data acts as your supervisor, right? We learned that in the previous lecture. Okay, good. Now, in unsupervised machine learning, obviously we don't have labeled data. So we talk about the unlabeled data. Now, how does the unlabeled data look like? Just simple data, right? You're not giving any output. So if you see, I'm just inserting a lot of pictures, but I'm not telling which is a cat or which is a dog. So this is an unlabeled data, and unlabeled data stands for unsupervised machine learning. Perfect. Let's take a look at its definition. So the definition says unsupervised learning involves analyzing and clustering unlabeled data sets. Now you might ask, but what is clustering? Clustering is nothing but another way of clustering is, you can say, grouping, right? You are just grouping the data. And now when you group the data, let's say this is cluster 1 and this is cluster 2. So cluster 1 is having similar types of data and cluster 2 is having other similar type of data, right? So you can think of it as, you are analyzing and clustering the unlabeled data set, and you are discovering hidden patterns, right? Because the aim of machine learning, as we learned in supervised machine learning, is you are understanding the patterns, and based on those patterns, you are making predictions. Patterns, predictions. The two P's are really important, right? Now, it deals with the data that has not been labeled, classified, categorized, and the algorithm tries to act on the data without any guidance, right? That's why it is unsupervised, because there is no labeled data which is supervising the machine learning program, right? So that's why this is unsupervised machine learning. Now you talk about clustering. So I gave you some simple example on clustering. So clustering is the most common unsupervised machine learning technique. It is used to group the data points into clusters, right? So you are grouping the data points into clusters. So this is cluster 1. It is of one data type of data points, and cluster 2 is other type of data points. So that items in the same cluster are more similar to each other. That's what I showed you. All the crosses are here, all the dots are here, right? So more similar to each other and those then in the other cluster. So all you are doing in clustering is you are grouping the data points into clusters. Now, again, a good example of clustering, if you see here, identifying similarities in groups. As you can see, we are just clustering them. Here, if you see, I've fed a lot of different pictures to the machine learning algorithm. Now the machine learning algorithm is actually working on it, right, and giving you the clusters. So this is one cluster, so you can call it cluster 1, and this is cluster 2, right? So here you can see it has grouped all the similar types of data in one cluster and other type of data in cluster 2. So all the cats are here, all the kind of dogs are here, right? So this is unsupervised machine learning. And unsupervised machine learning is really useful in market segmentation in the businesses, where the customers are grouped based on the purchasing behavior. So you can easily see, or the companies can see the purchasing behavior, and they can group those customers and maybe do some kind of adverts accordingly for them. Next one, very important, association. And I'm pretty sure you would have seen association when you are on Udemy, right? So what does Udemy do? So this technique identifies set of items in your data set that frequently occur together. Now here is a perfect example of association. Now let's say you are going to purchase an Oracle Cloud, say foundation course, right? As soon as you go to purchase that course, you will see that Udemy is actually telling you that, hey, these are the 3 courses that are frequently bought together, because they are studying the patterns of other people, right? So this is machine learning. They are studying the patterns of other people who have similar interests of you, and they have actually gone and purchased these 3 of my 3 courses together, right? So it is like a combo you are getting, right? You're getting all the 3 courses with a reduced price, and that's what machine learning is now telling you or giving you as a recommendation as well. You can say that, why don't you purchase these 3 courses together? This is association. So perfect example is in retail, finding the products that are often bought together to optimize the store layout or cross promoting the product. As I gave you my example, when you purchase my course, you will see that it will automatically associate all my courses and say, or my courses on specific topics. Like, it's not giving you cybersecurity because I have a course on cybersecurity. It won't show you here. It will just show you the Oracle Cloud or OCI related or Oracle Cloud ones here together, right? So not the cybersecurity one. So this is association. Then we do have a concept of anomaly detection. So this is actually used for identifying unusual patterns, right? Now, as I said, that the aim of machine learning is to identify patterns and make predictions. So here you are identifying your unusual patterns. So here example we give, like a hacker who's intruding into your network, right? So here anomaly detection can be really useful, right? And you can easily detect frauds as well. So let's say you look at various transactions and you see these set of transactions fall in a specific category, and these are different ones, right? So you can easily make out that there is a different behavior. So this is a different pattern and this is a different pattern, right? So you can detect fraud transactions in banking by identifying the patterns that deviate significantly from majority of the data. Right now, you might ask, okay, but in which applications you can use? So you can use in bioinformatics, speech recognition, image recognition, as we just saw some examples. And perfect example is recommender system, right? Something what I showed you on Udemy, similar way on Spotify, on Netflix. We've talked about Netflix a lot. The recommender system would utilize that because it would actually group users with similar interests, right? As I said, if you are watching a lot of, say, thriller movies, then you would be shown thriller movies. Same way, if you are purchasing a lot of going through a lot of OCI courses, Oracle Cloud courses, you'd be shown Oracle Cloud courses. You won't be shown the cybersecurity courses, right? So these are the various applications. And yes, it does come up with own challenges, and the biggest challenge is because if I quickly compare with supervised learning is much easier. Why? Because you know the output, right? You know this is a labeled data. Here the problem is your data is not labeled, right? So it is more difficult than supervised learning due to the lack of labeled data. And the other big big challenge is to determine the right number of clusters in a data set without predefined categories. Now, just think about it. It can be so complex that here it was a simple example of cat and a dog, and you were easily able to create 2 clusters and job done. But what if there are a lot of variety of data in it, right? So there it becomes a problem. How many clusters do you want to come up with without even knowing the categories they fall under? So like these are the kind of challenges the data scientists have to work on. So with this, we come to an end of unsupervised machine learning, which has 2 types: clustering, association. Thanks for watching. So in the previous videos, we learned about the supervised machine learning. We learned about the unsupervised machine learning. Now it's a time to take a look into the third type of machine learning, which is called reinforcement machine learning. Now again, as I always say, always look at the root word. Now, what is the root word, or what do you mean by reinforcement, right? Reinforcement means to further strengthen or to give further strength. So you can even think about it that you normally we use it with army, right? So let's say there is an army deployed in this area, right? To further strengthen that, or we normally say we are sending a reinforcement army, right? So you're basically just strengthening your process. Or in terms of machine learning, you can think of it, you are doing a reinforcement, or you are strengthening, or you are moving towards more accurate models. So the ultimate aim is to achieve maximum amount of accuracy, and you are improving on it as well. And this works on a concept of feedback. So you're constantly getting the feedback and you're improving on your algorithm or your model, right? So the core concept is there is a concept of agent. First of all, remember there is an AI agent within reinforcement learning. So whenever you talk about reinforcement learning, there will always be a mention of an AI agent. So this involves actually the agent learning to make decisions by performing the action and receiving the feedback, right? Again, very important thing, there is a concept of reward and penalty, right? Just think about it. Again, I take an example of a baby, right? Or a student. You can think about a student, right? Normally, the teachers would always give you some reward if you do some good work, or they would give you some penalty, right? In some countries, you call it consequence, or you could even say some punishment, right? Same way, what is the aim? The aim is to improve you as an individual, as a student, because the teacher wants you to be a bright student, right? So if you do something good, you get a reward. If you do something bad, you get a penalty. Same way, the concept of reinforcement machine learning, it says that it is done where you need to perform the actions and you receive the feedback in the form of reward or penalty, right? So as I talked about the AI agent interacts with its environment, and each time step, the agent receives the environment state, right? So you are actually, let's say you do some actions, you get the state of the say environment, and based on that your reward or penalty is decided, right? So this is quite important. And the key components are agent. So agent is learning from the environment, right? So you can say the heart and soul of a reinforcement machine learning model is an AI agent, because the agent is learning from the environment, right? And environment is where the agent perform the actions. Now here you can take an example of a chessboard or a game of chess, right? So your environment is chess, a game of chess, or the chessboard. This is the place where the agent is performing the actions, right? What are the actions? Now, actions are all the moves. If you see, this is one move, right? If I'm moving my king from here, I'm moving my club from here to here, or moving my horse from here to here. So this is a move, right? So the set of all the possible moves that an agent can make is called an action. Now, with action, there is a reaction, remember it, and that is in the form of your feedback. But how do you get that? You get it based on the state. You check the state of the environment. As I said, the current situation is returned by the environment, or you are returning the current state. So once your current state is returned, then it identifies, oh, was your previous move a good move or a bad move? If it was a good move, you get a reward. It means your machine learning algorithm is working well. If your move was a bad move, then you get a penalty, right? So that's why it's very important that you get the feedback from environment. Perfect, right? So agent is learning from environment. Environment is nothing but your game of chess or chessboard. Action is the moves that you are making. State is that after every action, there is a reaction. Remember, after every action, there is a reaction, just to understand it, right? And that reaction is in the form of, first you get the state of the environment, and based on that, you can make out whether it would be a reward or a penalty. And the learning process is pretty simple. The agent is learning, and the strategy of choosing an action given a state to maximize the cumulative reward over time. So the aim is to get maximum rewards, right? If you are achieving maximum amount of rewards, it means you are in the right direction. Now, there are two keywords: exploration and exploitation. Always remember, exploration means you are trying new things, right? Now, in the game of chess, you want to explore it, right? You want to try different things, but you want to exploit as well. Exploit means whatever information you have, you want to make use of that, or you can say you want to leverage the existing amount of information that you have, right? So you need to have a balance. So it can't be that you're just simply trying new things. If you're trying, then we are talking about a lot of trial and error. If there's a trial and error happening, maybe you don't have an accurate machine learning, say, algorithm or your model, right? So you need to balance it out. You need to balance your exploration, where you're trying new things and you're exploiting new things, and you're exploiting as well. You're using the existing known information, which is a key challenge, right? Now, applications. Now, I already spoke about that a lot. Game playing, the game of chess, or Go is another game. Then there is robotics, then autonomous vehicles. All these are good applications of reinforcement machine learning, because you are learning, you are improving. If I talk about autonomous vehicles, right, where there is an app or there is a company, Waymo, you might have seen that. So they are constantly improving. They are trialing this in San Francisco. If that car meets with an accident, that is a penalty, right? They need to see what exactly happened. Why did the car meet with an accident? It means they need to improve their algorithm. They need to improve their model further, right? So it is a perfect example of reinforcement. And yes, it does come up with their own challenges. It requires a lot of data. Obviously, we talked about data quality and data quantity. Again, it's very important that you should have good amount of data. And you need to balance the exploitation and exploration we talked about, right? You need to balance out trying new things. You need to balance out knowing using the known information. And you should know how to deal with the environment with a lot of variability or uncertainty, right? This is a game of chess, but they keep talking about autonomous vehicles, right? You are going on a road, right? Your car is going on a road. It's kind of a variable kind of environment, right? A lot of uncertain things can be happen. Somebody can just come running on the road, or a child can come on the road to get a ball from the road. You never know, right? Or a cyclist just simply falls down or trips over, right? So this is like very uncertain kind of environment, right? But these are the challenges, and this is where data scientists are working towards. That is reinforcement. You are strengthening your model, and it's all based on the feedback, reward or penalty. With this, we come to the end of the lecture, reinforcement machine learning. Thanks for watching. Hi folks, welcome back. So there's a very important concept of Jupyter notebooks. Now, I just wanted to give you a good understanding of what is a Jupyter notebook, because when you are actually working in the field of machine learning, data science, or artificial intelligence per se, you should have a good understanding of a Jupyter notebook. So a Jupyter notebook provides an interactive environment for writing and running code in a variety of programming languages, most notably Python, right? So this is how a Jupyter notebook looks like. So if you see, there's a concept of cells, and we'll talk about that as well. But what it is that you can actually write your code. If you see here, we are writing the Python code, right? And you can run the code as well within the same interface, right? That is the beauty of a Jupyter notebook. So you're writing here and you are seeing the output there itself. Right? And so Jupyter notebooks can be actually used for a lot of programming languages, but mainly with data science and machine learning, we use Python. And as I said, there is a live code execution. So if you see here, we are writing a code, and if we execute it, we can easily see the output as well. So output comes here itself, right? That's the live code execution. So you can, so code cells within a notebook can be executed independently. So I can execute this independent of this code cell. So this is one code cell, this is other code cell. I can execute this, then independently I can execute this, see the output, and move on to the next one. As I said, it supports multiple languages. So don't think that Jupyter notebooks are only for Python. They can be used for around 40 programming languages, which includes R, Julia, Scala, but here again for machine learning we are utilizing Python. And yes, unlike other notebooks, it has got rich text elements. So you can include text narratives, markdowns, equations, images. As you can see, you can have images, you can have links, which actually allows a comprehensive documentation of the code along with its explanation. So that's the beauty of a Jupyter notebook. And yes, data visualization as well. So there is a clear integration with data visualization libraries like Matplotlib. So you might learn about Matplotlib. Matplotlib is nothing but a library in Python, which is used for creating static, animated, interactive visualizations in Python, right? And there are other libraries like Plotly, Bokeh, which helps you to create interactive graphs. So if you actually see again this example code here, as soon as I execute this within the code cell or just underneath the code cell, you'll see the output, and that is more of like an interactive graph that actually comes up based on the code that you have written, which is the good thing about Jupyter notebooks. And yes, you can share with others. So you can easily convert a Jupyter notebook into different formats, like you can have it in HTML, you can create in PDF, and even you could create in slides for presenting and sharing. That's why Jupyter notebooks are so popular. And it is widely used in the field of education and research. So it is widely used in academia, like academics, universities, and also for research projects, for teaching, programming, computational thinking, and data analysis, right? And yes, there is a clear integration with several data science tools. So any data science tool that comes up, you will see that you will have integration with Jupyter notebook. So we'll talk about data science tools like Anaconda, and in our next video we will actually take a look how you can utilize Anaconda to run Jupyter notebooks. And even when we talk about Oracle machine learning or Oracle machine learning tools, there also you'll see that you will have the capability to use Jupyter notebooks. So yes, there is integration with data science tools, which helps you to integrate with tools and platforms, which helps you to facilitate tasks such as data cleaning, statistical modeling, machine learning, and many more tasks. So guys, that's why I just wanted a video on Jupyter notebook to give you a good understanding. In the next video, we will actually take a look at a demo, how you can use Anaconda, how you can use say Jupyter notebooks, and then from there onwards, we'll see another demo on machine learning. Thanks for watching. Okay, so now I'd like to introduce you to Iris dataset. Now, what is iris dataset? I think in one of our previous lectures on machine learning, I actually showed you, especially it was, I believe, the supervised machine learning, where we talked about the labeled datasets, right? So here I'll talk about iris dataset. So this iris dataset was actually used in R.A. Fisher's classic 1936 paper. Just imagine, it is that old, right? And it is also found on the UCI machine learning repository. So what it is, right? It is a set of, you can say, features, where it gives the features like sepal length in centimeters, sepal width. So I told you, like, there's an iris flower, and iris flower has several species, right? And now in this data set, what we are doing is we are actually looking at several features like the length of the sepal, the width of the sepal, the length of the petal, and length or width of the petal. And then we are, because it's a labeled data set, we will actually tell that whether if you have this as a length or width, then you fall in under which category, right? So and mainly the categories are like iris setosa, there is iris veriscolor, and there is iris virginica, right? So basically there are three main categories, and there are 50 rows each for each of those categories. So this is the kind of data set, right? So our aim is first to understand this data set. So you can easily download it from here as well. It is available. Otherwise, I will upload in the course as well. In the resources section, you can get the iris.csv file. Now, the thing is, how do you utilize this data set? So let's quickly take a look, right? So all you need to do is you need to follow as I go along. So first we need to do is we need to say import this library. So we go back to our Jupyter Notebook, and all we need to do is we need to import this library, which is pandas, which is a Python library. And all I'm saying is data equal to pd.read_csv. So here you need to give the path of your iris.csv or the data set, right? And then we just need to see the head of it, right? So we are saying data.head. So first it is putting the entire CSV in a data variable, you can call it that way. And then when you do data.head, it can show you like the top 5 rows, right? Here you can easily see this is a labeled data set, right? You have the sepal length, sepal width, sepal, say petal length, petal width, and then you're also telling that which category does this belong to, right? Because this is your, you can say, training data, right? As I told you, there is a testing data, training data. This is your training data. You will be training your model based on this. So don't worry. Let's go to the next one. So then we look at the rows and columns. So all you need to do is you need to do data.shape. So data.shape will actually give you the actual rows and columns. So it shows that there are 150 rows and there are 6 columns, right? Simple, right? Nothing much to explain in this. Then we go further, and we let's say now you are interested in only because it's displaying so much. So let's say you are interested in only displaying specific columns, right? So all you need to do is you go back, right? And you are saying you are just interested in specific data, right? So out of all these columns, you are interested in, say, ID column, and you are interested in species column, and you want just the top 10 records. So if I execute this, you'll see I'm just getting 1 and iris setosa. So outside all of that CSV file that you have, you're just displaying the ID and species. So with this, I just wanted to give you a good understanding of iris dataset. Now things will get interesting. Now in the next video, we will utilize this iris dataset and create our own machine learning model, and we will train the model, and then we will see some predictions coming out of it. So things are getting interesting. Keep watching. I'm pretty sure this is the video that you guys have been waiting for quite a long time. And time has finally come where we'll be working on the iris data. And when I say working on iris dataset, you would be training. First of all, you'd be creating your model, you'd be training your model, and then we will try and get some predictions out. So does it not sound all interesting to you guys? So whatever we understood or whatever we learned theoretically, now we are going to apply those techniques practically, right? So let's get on with it. So what we have to do is we just simply take So as a first step, what we are doing is we are splitting the data into X and Y. So remember, I told you that you have the X-axis and you have the Y-axis, right? So here we are saying that in X-axis, I want all the features. And when you say drop, I'm saying don't take the data which is related to ID or species, because this is remember, this was our labeled data set, right? So species is actually our output. So here, that's why the X-axis, we will have all the features. So and Y-axis will have the features itself, the species itself, right? So let's take X and Y. So let's go back to our model or Jupyter Notebook, and we say X is drop columns, right? So we are saying drop the columns ID species. So we are dropping this column completely ID, and we're dropping species. So what are we left with? We are left with sepal length, sepal width, petal length, petal width, right? This goes on our X-axis, right? And Y-axis has the actual species. So it's the same concept of dependent variable and independent variable, right? So, so species is you can say the dependent variable, and all these are kind of independent variables, right? Perfect. Now we actually go and say print. So let's say you would obviously want to see what is in my X and what is in my Y. So I go back, I say print X.head, Y.head, right? And what do we get? So for X.head, so let's actually do it one by one. It would be better. So print X.head. So what do you get in print X.head, right? So you are getting, as I told you, all the remaining data, right? Except the ID and species. So you're getting the sepal length, sepal width, petal length, petal width, right? Same way, if you do print Y.head, as I said, Y is your species. So if you do this, you will get all your species like Aristatosa, Virginica, right? What all species you have, that you get. Okay, perfect. Now what we need to do is we need to go back and we have to create our own machine learning model. Yeah, it's pretty simple. We are using just simple Python. So what we will do is we will create a machine learning model and we'll initialize the model with default settings. So the concept is you use sklearn.linear model, and remember, we are using regression here. So you learned about the regression technique. Here we are actually utilizing the regression practically, right? And you're using a variable ML machine learning underscore model and logistic regression, right? So just simply copy, take it over there, and simply run the code. And I will always recommend that you just simply do the way I'm doing. Just simply copy one at a time, right? One step at a time. Now we will actually train our model, okay? So as I said, training data is always different from testing data. So you're training the model on the features X. What are the features X? The features X are sepal length, sepal width, petal length, petal width, with corresponding labels Y, right? Now you're telling your, say, algorithm that, hey, look at this data set. So I'm training you on this data set, correct? So let's train our model. I say, so this is, I'm using logistic regression. Okay, all good. Now, what did we study? We said you have to look at the patterns, and then the model needs to give you the predictions, right? So let's first test the prediction using a trained model. Let's say now our model is trained, right? And our model name is ML. So ML underscore model, right? That is our model. And now I'm using another variable which is ML underscore predictions. So and now I'm here using a test data, right? As I told you, test data is always different from the trained data. And just think what I'm giving. So I'm giving us a specific value. I'm telling the computer that, hey, I've got this new data set which has got this sepal length, this sepal width, this petal length, and this petal width. Now, based on your intelligence, can you now tell me that which category of iris flower does this belong to? So the computer needs to just look at this data set, right? And now it has to give me the output, whether it is Iris setosa, it is varicula, virginica, what type of flower is it, right? So we run this, right? And then we simply print it, right? Now we will print the predictions. As simple as that. So nothing difficult, right? So now we are saying, can you now print the prediction that you did? Perfect. See, that's the beauty of machine learning. I just gave it the features. Just based on the features, it was able to tell me that whether this thing or this picture is a cat or a dog. In this case, I'm telling, based on these features, it was so intelligent. My model is so intelligent now that it can accurately tell me that which category of iris does this belong to. And it gave me, yes, this test data should be related to Iris setosa. So I guess this was a perfect, simple example of machine learning and how you can use machine learning practically. Thanks for watching. Hi folks, welcome back. So things are going to get more complex and more interesting. Why? Because now we are going to learn about deep learning, right? As the name suggests, deep learning. We are going to get really deep into this. Now, the best way to understand deep learning is, remember that here the scientists are actually talking about looking at the ways in which how a human brain works, right? Now, if you ask me, the main thing that you need to be aware of is that inside a human brain, we have neurons. So a human brain is made up of neurons. And now what are neurons? Neurons are nothing but these are the nerve cells that send messages all over your body to allow to do everything from breathing to talking. And the main thing that you need to remember is that these neurons are interconnected, right? They are interconnected to each other. And as I said, they allow you to do everything from breathing to talking, eating, walking, thinking. So whatever you are doing, all that processing, all the messaging is actually being done by these neurons, right? So always remember that whenever you talk about deep learning, you're talking about how a human brain works. And this level of intelligence needs to be added in your computer program, in your computer model. So always remember that. And the other quick thing I would like to reiterate is we did study that deep learning is a subset of AI or machine learning. So in the outer layer we have AI, in the middle layer we have machine learning, and the middle layer we have the deep learning, right? So let's take a look. So deep learning is a machine learning technique that teaches computers to process the data in a way that is inspired by human brain, right? As I told you, with human brain, we have neurons or the nerve cells. Same way, we try to use the same concept in deep learning, right? So with deep learning, as in human brain, you have neurons which are interconnected. Same way, we have a concept of neural networks. That is what they call the neural networks. And again, you will see that it is all interconnected. So at the heart of deep learning are artificial neural networks, which are algorithms, right? At the end of the day, it is nothing but these are computer programs, right? These are algorithms that we are following, which are inspired by the structure and function of the brain. Again, as I told you about neurons, interconnection of these neurons, this is actually a human brain neuron interconnection. Same way we have the interconnection of the neural networks, right? So a human brain contains millions of these interconnected neurons. Remember, we are not talking about 10 or 20 or hundreds of these neurons in a human brain, right? We are talking about millions and millions of these interconnected neurons, and they work together. As I told you, eating, drinking, sleeping, whatever we are doing, the processing of messages, this is all happening with the help of neurons, and they are all interconnected with each other. So this is a human brain, and this is how a neural network looks like. So Doesn't it look similar? Yes, it does. You can think of it like these are different neurons, like neuron 1 connected to neuron 2, connected to neuron 3, and same way they are like interconnected to each other. So artificial neural networks are made of many layers. Remember, we call them layers. So this is one layer, this is second layer, third layer, and there could be several layers, right? So these are made up of many layers of artificial neurons that work together inside the computer. So as I told you, there is a neuron in human brain. Same way in artificial neural networks or neural networks, we have neurons, right? And because they are not real neurons, we call them artificial. So what did I tell you in our very first lecture? What is artificial? Something that is man-made, right? So that is why we call it artificial neuron. It is not the human neuron, right? And yes, very important feature. Now you need to remember, we studied about machine learning. So in machine learning, we saw that you give the input, you do some kind of feature extraction, right? Let's say I'm talking about labeling my data. Like let's say you're giving the pictures of cat, dog, and you're labeling them. Okay, this is a cat, this is a dog, and you're also looking at the features. What is the length? Or when we talked about the iris flower, we talked about the sepal length, sepal width, and we labeled it. And then we pass it through the classification, and then you get the output. Now, the scientists thought that, okay, it's all good, but here you have involvement of a human being. Why don't we, sorry, why don't we get rid of this human being and bring the entire thing into a neural network? And this is what a neural network does. So you are removing the dependency on the human experts. So whatever things like feature extraction that a human being was doing here and then passing over to classification algorithms, we have combined these two together into a neural network. That's the beauty. If you see feature extraction, classification, it's all getting combined and there is no role of this human being here, right? So it removes some of the dependency on the human experts. Now, it's not completely, you need to remember, we're not completely getting rid of humans. It is just some of the dependencies being removed. Okay, now the thing is, what are these now different layers of neurons? And in the next lecture, we will study about neural networks, so you'll get more understanding. But deep learning models consist of layers of interconnected nodes or neurons, right? As you saw, they are all interconnected, right? And deep refers to the number of layers through which the data is transformed, right? That is how you get the word deep, because there are so many multiple layers that you have to go through, or the data has to go through as part of the data transformation, right? So that is why it is called deep learning. And yes, deep learning excels at learning from unstructured data, right? And not like machine learning where you are giving labeled data or even unlabeled data as well, right? But here it is even unstructured data. The data doesn't have any kind of structure. So it is up to the machine learning, or I should say deep learning program or model to find out, to figure out, okay, what kind of feature differentiation I need to find out, right? So this is all done based on the intelligence of the model. So deep learning excels at learning from unstructured data, like it could be images, text, or sound. So an example we give is recognizing faces using the convolutional neural networks. Now you might have seen in certain movies that they show that, okay, they are looking for a culprit and they're looking for several photographs and they're going through and they're trying to match it with the actual photograph, right? So this is how it would be like you're recognizing a face in the images. So this is a convolutional neural network. And yes, it is deep. So obviously you need large data requirements. So you need to actually gather large amount of labeled data for training. So you can't just go with 100 or 50 or thousands of records. You need really large amount of data to train your model. Only then you would get accurate results, right? And yes, because you need large amount of data, obviously you need processing. So we have a concept of GPUs, which is called graphical processing unit. Don't worry if you don't understand this. When we go to the AI infrastructure, we'll do more deep dive into GPU. I'll show you a demo of how GPU works as well. For the moment, just remember, because you have to process a large amount of data, obviously you need large amount of computational power, and that large amount of computational power is coming with the help of GPUs, or the graphical processing units. Something similar, what we had CPUs, now we will have GPUs, right? And yes, it can be used in versatile applications, like it could be used for various applications like autonomous vehicles, self-driving cars, medical diagnosis, and NLPs, or natural language processing. Pretty self-explanatory. And yes, very important, there are the tools and frameworks that you need to be aware for deep learning is, there are tools like TensorFlow, there's PyTorch, and there is Keras. So Keras is one of the library. It is a library. We call it a deep learning library of Python. Right? It's a deep learning library for Python, which is used for building and training the deep learning models. And don't worry, we'll have an exciting demo using the Keras library as well as part of the upcoming lectures. So I guess with this, you get a very good understanding of what is deep learning. Remember, deep learning, whenever we talk about, always think about how a human brain works. Thanks for watching. So after studying what is deep learning, it's time to take a look into what is a neural network. Now, just a quick, I would say, summary. So deep learning is nothing but it's a machine learning technique that teaches the computers to process the data in a way that is inspired by the structure of a human brain. Now, what did we learn in the last video? That your brain has millions of neurons, and these neurons are kind of interconnected to each other, right? So there are several layers of these neurons, and these neurons are the ones, or neurons or the nerve cells are what helps us in eating, drinking, sleeping, making decisions. So it's all interconnected through our body, and that is what is the heart of deep learning. And so if I say the heart of deep learning is a neural network, right? So now we call it neural in terms of, or nerve cells in terms of a human brain, but with neural networks, we normally call them artificial neurons, right? Now you might ask, okay, but what is a neural network? So neural network is nothing but it is a machine learning program or a model that makes decisions in a manner similar to the human brain. Very important. Again, it makes decisions similar to how a human brain does. So you will see when we look at the structure of the neural network, it is also formed in the same way. So scientists thought how our brain functions, where neurons are interconnected to each other. Let's create artificial neurons and let's connect them to each other so that some decision making can be done, right? And it helps you to mimic the way the biological neurons work together to identify the phenomena, right? So same way, as I said, like the human brain where neurons are interconnected, same way your these artificial neurons are interconnected. And when we talk about the structure is normally you can say kind of three levels, but they can be multiple layers. Normally we say this is the input layer, right? The first layer where you input your data, output layer as the name suggests. And then we have a concept of hidden layer. And these hidden layers can be multiple layers. Remember, these can be multiple layers. And hidden layers are what makes a neural network deep, right? Because we are studying deep learning, and these hidden layers are the one which makes a neural network deep and enables them to learn complex data representations. So very important, you have input layer, you have hidden layer, and then you have the output layer. And each neuron performs a simple calculation like a weighted sum, which is followed by a non-linear function on its inputs. So the best way to understand is, let's say we give the computer or our model the image of a circle. Now this circle comprises of 28 by 28 pixels. And what happens? Each pixel is sent to each neuron. If you see, we are putting each pixel in each of these neurons, because 28 times 28 is 784, correct? And if you see, we are putting each pixel in each neuron, right? Now, these neurons are interconnected. As I said, one neuron is connected to the other neuron, and this interconnection is called a channel. Always remember, this is called a channel, right? And these neurons have a weighted sum. So the other thing is that if we again take an example, so it's, if we are talking about x1 and x1 here, so you see x1 times 0.8, right? This is the weight, right? So x1 times 0.8, and it is connected with which? It is connected with x3. So x3 times its weight, which is 0.2, and we add it to a bias. This is called a bias, and you will learn further. And this actually helps you to give an activation function. Now, what is an activation function, you might ask? So an activation function decides whether a neuron should be activated or not. Now, let's say if this is activated, then obviously it moves to the next layer. This way we call that it is a forward propagation happening, right? So it is flowing from here to the next neuron, and once the same thing is done on the next neuron, then the forward, and then it goes on to the next one. Right. And we do have a concept of backward propagation. So let's say if the result that we are getting is not correct. So let's say it says that, okay, I identified this to be a square. It was actually a circle. So it means that there is some problem in our weights and calculations. So what happens as part of the backward propagation, what happens, it can readjust these weights. So this 0.8 could be 0.6. This could be 0.4. So this is the readjustment of weights that happens, right? For the moment, just don't go into too much of depth. Just remember, all we are doing is we are just giving this image. It has 28 by 28 pixels. Each pixel is given to each neuron, and these neurons are interconnected to each other. And based on the training process, we can come out that whether the results are right or not. If the results are not right, then as part of the backward propagation, you can always readjust the weights. So the learning process is pretty simple. So neural networks learn to perform tasks by considering examples. So we say it is learn by example. And this is what humans do as well. They learn by example, right? You see different things, and based on that, you are able to identify whether it's a cat or it's a dog, right? Same way the neural networks are learning from this. And as I said, the connection between the neurons have weights. So this 0.8 is a weight, right? That adjusts as the learning proceeds. So as I told you that if your answer is not correct, or if it is not accurate, so you can readjust. The neural network can readjust your weights, right? The network also uses biases. Now biases is something like B1, B2. These are the biases, and biases are nothing but there's an extra input you're giving to the node. So remember, there's another word for neuron. We call it a node. A neuron is also known as a node, right? In each layer to help them make better decisions. So remember, there's a concept of weights and biases, and these weights and biases will lead to an activation function, which decides whether this neuron gets activated or not. Right? So there are different types of neural networks. Don't worry about it. We'll do it more. We'll understand more examples in the next video. There are normally feed-forward neural networks, convolutional neural networks, also known as CNNs. Then we have recurrent neural networks called RNNs. And anyways, we'll take a look in the next video. So some examples. So image recognition, right? CNNs, or the convolutional neural networks, are used to identify the objects, faces, scenes, something like this, right? So you are able to identify. So in this image, you are able to identify, oh, this is a keyboard, this is a screen, right? This is a car, right? So this is a tree, this is a building. So this is all being done with the help of the image recognition, or CNNs. Then we have a concept of speech recognitions. In speech recognition, we have recurrent neural network. They are commonly used to for speech recognition in virtual assistants like Siri or Alexa as well. So normally with Siri also, you've seen that it can recognize your voice, right? So you just say a specific word and it wakes up. And same way with Alexa, it wakes up, right? So it is able to identify the voice. Then we have a concept of predictive text, neural networks are used in keyboards on smartphones to predict the next word. Like, let's say if I say hello, how are. So if I'm saying hello, how are, so it's intelligent. It knows that probably I'm going to write you only, right? So it will give you a predictive text. So this is a predictive text. It understands based on your behavior of writing what you're about to say. Yeah. Then yes, we have some applications beyond these examples. We have applications like they're used for self-driving cars. Again, autonomous vehicles. Waymo is a perfect example. You can read about it. It's a self-driving app. Then it is used in medical diagnosis, stock market trading, very important, and many more applications. So if you see, examples are still the same. What we learned with machine learning, deep learning, even neural networks. It's just the way, the kind of accuracy which is improving as we are moving from machine learning to deep learning, and probably when we go to more Gen AI side of the things, the aim is to make, as I said from the very beginning, all you are doing in all this is you are identifying patterns. And what are you doing? Which is the second P? Any guesses? Yes, you are making a prediction. That is what the aim is. So with this, we come to the end of what is a neural network. Hi folks, welcome back. So in this video, we'll take a look at some of the important deep learning models, right? And there are certain other terminologies that you should be aware of when you're learning deep learning or artificial intelligence. So just a quick summary, as I told you in the previous lecture, that when we are talking about the artificial neural networks, all you are doing is, let's say you have this picture or this image and it's divided into several pixels, right? Now each pixel is given to each of these neurons, and they are then fed over to the next layer in the neurons, and this is how they are interconnected through channels, and they have a concept of weight and biases, right? And based on that, this is the input layer, and you are able to get the output layer. And if your output accuracy is correct, then it's all good. If the accuracy is not correct, then you can make corrections via the backward propagation, and you can readjust your weights, right? So it's as simple as that. So now there are different types of models in deep learning, and the very first one we learn is called a convolutional neural network. Now again, as I always tell you, always look at the root word. The root word is convolution. So if you study about convolution, is nothing but, if simple English meaning is something with a lot of twists and turns, right? It's a convolution. Or even if you talk about in terms of mathematics, it says it's a mathematical way of combining two signals to form a third signal. But I would say you can think of it as, again, it's a deep learning methodology. Convolution is nothing but which is having a lot of twists and turns. So you have to go around several loops. You can think of that way. So convolutional neural networks are actually ideal for image and video processing. So as we saw, like, okay, you want to see whether it's a cat or a dog, you will actually consider a convolutional neural network, right? And it's the best example is image classification in social media platforms, as I said, distinguishing between a cat and a dog. Then the next one is recurrent neural network, again RNN. So recurrent is something which is repeating itself, right? Very important. Again, the root word is repeating. So if you see here that if the input, so here we are taking an example of how do you predict the tomorrow's stock price, right? So you give some input, and the input is based on yesterday's and today's stock price, right? So this is your input. Obviously, as we studied here, there's a concept of weights and biases. So these were kind of weights and these were biases. So same way, you are giving some weight and you have biases, and based on that you are getting the activation for this, right? Activation function you are getting. Now based on that you are actually getting your output. So the output is nothing but the predicted stock price for tomorrow, right? So this is what we call a recurrent neural network. So a recurrent neural network is designed for sequential data such as time series or natural language as well. So again, something what we studied, if you have to predict the next word in a sentence with the auto completion feature, like let's say in my smartphone, if I'm writing how are, as soon as I write it would know that, okay, probably I'm going to say how are you with a question mark. So right, so this is what is an autocomplete feature within this. So it makes use of the recurrent neural network. Then there's another type of RNN which is called LSTM, which is long short-term memory network. right? It is a type of RNN which is effective in learning from sequence with long range dependencies, right? Best example is a Google Translate, right? So if I write something here in English, hello, how are you? Right, so the translator is able to identify that this is English and it can translate to some other language, whatever I give, let's say French, and even it can be used based on the translate by voice as well. So this is a perfect example of LSTM, which is used in machine translation services like Google Translate, right? Next one, GANs, very important, guys. They are really getting very popular these days. So GANs have a concept of two networks. So this is one network, one neural network, and this is the other neural network, right? So one is the generator, other is the discriminator, and they are competing against each other, right? So it's basically the thing is that this is real and this is fake, right? So what you're trying to do is you have you know about the real, but you are trying to generate. So here you are generating something like a fake video or fake image, right? But it should be as real as possible, right? So this is what is called a deep fake video, deep fake. Now, as the name suggests, it is deep, it's part of the deep learning, and it's a fake video. And it looks so realistic, and it's basically what you're doing is you're creating a new footage that depicts the events or the actions that have actually never happened. That's the beauty of a GAN, right? So it is having two networks, a generator, discriminator, which compete against each other, and you can create photorealistic images or deepfakes. Then very important, I would say, the heart and soul of Gen AI is a transformer model, right? So when we study Gen AI, which is becoming super hot these days, generative AI, the base or the heart and soul is transformer model. It is based on the self-attention mechanism for handling sequential data. And we'll look at transformer model in more detail in the next lecture. Before the moment, you can think about it as it's the best example is OpenAI's GPT-3, right? You all know about ChatGPT and all. So ChatGPT-3 or GPT-3 for generating human-like text, like in applications like chatbots or content creation, right? Simple. If you have to write a poem, right? If you have to write an essay, if you have to write a letter, right? All these are using the transformer models within GPT. So I think this was more of a lecture for getting some basic understanding. We haven't gone too deep dive because then it becomes really complex. But for the moment, you can just understand what deep learning models you should be aware of, like convolutional neural network, CNN, for image or video processing. Recurrent neural network, RNN, which is used for like predicting the stock price or predicting the next word in a sentence when something like an autocomplete. Then we have LSTM, which is long short-term memory network, used for more, you can say Google Translate. Then we have concept of GANs, which is used for, the deepfake videos. And we have the transformer models, which is the base or heart and soul of the generative AI. So with this, we come to the end of the lecture. Thanks for watching. Okay, so it's now time to do a quick demo on the deep learning methodology that we have learned so far, right? And for that, as I explained to you, there's a website Kaggle. If you go to Kaggle, there is a PIMA Indians diabetes database. Now, who were PIMA Indians, right? So PIMA Indians were a group of Native Americans living in an area consisting of what is now the central or southern Arizona, right? So what they've done is they have actually created a database, and it is a diabetes database. Now, if I quickly read about it, so this data set originally from the National Institute of Diabetes and Digestive and Kidney Diseases. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes, right? So what it will do is you'll see that it will have several features, right? Or you can say several metrics that are given for a lot of other patients. And based on those metrics, it has to decide whether the patient has diabetes or not, right? So several constraints were placed in the selection of these instances from a larger database. Another important key thing about this is all patients here are females and at least 21 years old of the Paima Indian heritage, right? It's a specific area, and all the patients are females and over the age of say 21 years, right? Now one way is either you can download the data from here, or you can actually get it from the resources section. So if I actually show you from the resources section, this is how it looks like. These are the different values, and what these value mean I'll show you. But the last column is quite important, because 1 and 0s, which shows whether a person has diabetes or the person doesn't have diabetes, right? So what do these columns indicate? These columns actually indicate, the first one is number of times a person is pregnant, right? The number of pregnancies. The plasma glucose concentration. The third one is blood pressure, right? The next one is skin thickness, the triceps skin fold thickness. Then it looks at the insulin levels. Then it looks at the BMI, which is the body mass index. Then it looks at the diabetes pedigree function. It looks at the age of the person, right? All these are ages. And then it gives you the outcome 0 or 1, right? So that's quite important, right? So what we'll do is we will now use a machine learning model. So we'll create our own deep learning model based on neural networks, and we will try and use this diabetes database, right? So what I've done is, as I always say, best is you go along with me, so you can actually work on this. And what we'll do is we just simply go to our Anaconda. We'll launch a Jupyter Notebook, right? A new notebook gets launched. Right here you can say new Python, right? So you've got a new Python kernel. Before I go ahead, I just want to give you two terms, very important terms. One is the Keras and other is the TensorFlow. So Keras is an open source library that provides a Python interface for artificial neural networks, and Keras acts as an interface for the TensorFlow library. But now you might ask, but what is TensorFlow? TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. That's why in this demo, we will make use of Keras and TensorFlow. So the best way is, first what we need to do is we need to simply import our Python libraries, right? So we just simply import these libraries. So you just simply copy and you just simply paste into your, say the Jupyter notebook that we have opened, right? So I just simply paste, I run, right? All good. Then I do next. Then we need to load the data set, right? So it's the same data set that I showed you, this one, right? So we are simply loading this data set. All we are doing is we are actually giving the exact path. So here I've just given like my path in my MacBook, but if you have your own path, you can just change it, right? And we are saying it's delimited by commas. As you can see, various values are separated by commas. So we load this data set. Right. The next one is we split into the x-axis and y-axis. Very important. Which is the input x and the output is y. So output is where it says whether a person has diabetes, yes or no. Right. So again, you go here, you execute it, and quite important here is x-axis is from 0 to 7. Right. So from here it is up to this point, and y is the last bit, which is the last column, right? So y is the 8th one. Good. Then what we do is we define the Keras model. So as I explained you, what is Keras? Keras is nothing but the open source library that provides Python interface. So now we define the Keras model. So you just simply go there and execute it, right? You can run it, and then we compile the model, right? So we are saying its optimizer is Adam, the matrix is accuracy, right? You just simply compile the model. Okay, we've compiled the model. Then comes training the Keras model. So it's very important that you need to train the model, right? So the command for training the model is model.fit. You give the X, you give the Y, and you give the batch size, right? So let's say we train the model, right? Now your training is done. Very good. Now you need to evaluate the accuracy of the model. Let's see how accurate our model is, right? So if I execute this statement, it says, hey, it's around 77% accurate. What if we try to say train the model again? Does the accuracy improve? Let's see. So I train it again. I again check the accuracy, and let's see what it says. So yes, slight improvement from 77.21, it's improved to 77.34, not bad. So it means that that's where we say that the quality of the data and the quantity of data is really important. If your data is quite large and your quality is good, then obviously your say accuracy would be much better, right? Now you make some class predictions with the model. So now we are going to make some kind of predictions. Let's say what it does. So we run it, right? So it has executed. And now is the time to summarize the first test cases, right? So now we are looking to look at the first 50 test cases and see the results, right? So what we will do is we will execute it, and you'll see that whether it gives you the expected value or not. So in this case, our machine learning algorithm says that yes, this person is supposed to have diabetes, right? And expected was 1, which is good. In the next one, the expected is 0 and we got a 0, right? In the third one, say here we have 1 and a 1, good. So 0 and a 0, 1 and 1. There would be certain places where it might fail. So 0, 0, 0, say. See this case. Here, in this case, it is saying that our model predicts that the person doesn't have diabetes, but expected is 1. So this is where it's bit of the model is failing. So it's just because we've trained it on say a very small amount of data. So that's why if you have a lot of data, then obviously your accuracy and your model will improve over time. So I think now you got a good understanding. As I always say, that you are trying to look at the patterns, and based on the patterns you are making the predictions, and that's all we are doing. So previously you saw this in a more theoretical manner, but I think with this video you've got a very good understanding how it works practically using Python libraries, using Keras, using TensorFlow, how it all works, right? So I hope you enjoyed it. Thanks for watching. Hello and welcome. So if you ask me today, which is the hottest technology today in the IT world, I would tell you it is generative AI, right? Now you might ask, but what is generative AI? So before we actually start understanding what is generative AI, I would like you to I'd like you to be reminded of the onion structure that we studied in our first lesson, where I told you that the topmost layer is artificial intelligence. Then underneath it is machine learning. So machine learning is a subset of artificial intelligence. Then we understood deep learning, right? Where we saw the concept of neural networks, right? So deep learning is a subset of machine learning, and here comes generative AI. Remember, generative AI is a subset of deep learning. So whatever we learned in deep learning or neural networks, artificial neural networks, that acts as the backbone for generative AI. So if today you are learning generative AI, I would say you should have a very good understanding of what is deep learning, right? And we did good in-depth understanding of deep learning through neural networks. And also we studied several different types of models as well, right? So what is generative AI? So generative AI, as the name suggests, always go at the root word. I always tell you, generate, right? You are generating something. Generate is the root word. You are generating, you are building something, right? So generative AI can create wide range of content, including text, images, music, and even code. So remember, with generative AI, we are not only saying that you can create just simple text, you can even create music, you can create images, and even code. So you can ask a simple Python program or even a complex Python program to a generative AI software, and it should be able to generate or create, I would say, the Python program for you as well. So with generative AI, you're learning from data. So as I told you, data, it's very important that the quality and quantity, right, that always matters, especially when you're training your models, right? So these systems learn from large data sets. So quantity is really important, and obviously the quality, right? Because you are making patterns, you're understanding the patterns, and then you're making predictions. So that's where quality and quantity very important, which helps you to understand the patterns, styles, and enables them to produce similar kind of output, right? So it's pretty self-explanatory. As I told you, generative AI backbone is deep learning, right? So many generative AI systems use deep learning techniques, particularly neural networks. So you will mostly you will see that the backbone or the back end of a generative AI system, or if we today talk about ChatGPT, would be neural networks, which is helping you to generate or create the content. Now you might ask, but what are the applications? It's pretty simple. It's actually being used in various fields like art, right? So let's say you have to create a new image. In entertainment, you can create videos. In marketing, you can create nice marketing slides. Even software development, as I said, that you can even write code as well through generative AI, right? And we are improving the efficiency. So the data scientists are continuously working on it. By automating the creation process, it can significantly reduce the time and effort which is required to produce the content. So just think about the content creation, where the content creators had to write a lot of content, then they had to do a lot of editing. It is improving the efficiency, right? So previously you used to create the content, then you used to edit the content, then you used to say amend the content, proofread it, right? So all this used to happen. Now what we are saying is just give your input to a Gen AI system and it will give you the output. And there's nothing really which you can improve upon, right? Because it is already coming through a very deep learned kind of a model, you can call it that way, right? So you're automating the creation process. Yes, there are some challenges and ethical considerations. So there are concerns regarding the originality, copyright, and potential misuse of the generated content. So there is definitely a copyright problem, right? Anybody can use the ChatGPT, get the content and say, this is my original content, which is not the case, right? So this is where we need to be really careful if we are using something directly from generative AI systems. But for the moment, you can just understand that there are, yes, with generative AI, there are certain challenges you need to be aware of. And it is continuously, there is a continuous evolution happening, rapidly improving, I would say. Every day you will see new changes coming up, right? So generative AI technologies are rapidly evolving, becoming more sophisticated over time. And as we say, they are getting more accurate, right? And as the aim is nothing but prediction. So it is a user generated input. So these systems can start with a simple user input like a text prompt and expand into a full-fledged creation. So simple example, let's say if I say, can you if I say, can you write me a nice poem for my wife whom I met in London on a specific day, right? And you can just specify some qualities about your wife and all, and ask this Gen AI system to write a poem for you. And you will be surprised that it, within a matter of few seconds, it will actually come up with a complete poem, right? So that's why it's a user generated input. You are starting with simple, plain English. You are saying, please write me a poem on this, or write me an essay on this, or give me some bullet points on a specific thing, right? And it will expand into a full-fledged, text, right? And yes, we need to be aware of certain indisciplinary impact. So the impact is definitely felt across several disciplines, which is revolutionizing the traditional methods in the field of journalism, design, and education. So that's where we need to be really careful about these generative AI systems. How and where are we utilizing these systems? So for the moment, it's best to understand that generative AI is a subset of deep learning. And generative, as the name suggests, generating or creating, you are creating new content, right? That's the major difference. And in the next video, we'll take a look between a difference between predicted AI and generative AI. So thanks for watching. Okay, so $1 million question, which is always asked, is what is the difference between predictive AI and generative AI? What if I tell you whatever we learned so far, right? Where in terms of we learned about artificial intelligence, we learned about machine learning, we learned about deep learning. So all these things where we were actually looking into patterns, and based on the patterns, I told you, what are you looking for? Yes, predictions, right? So all this falls under predictive AI. But then what is generative AI? As I told you in the previous lecture, generate, like you are creating new content. Always remember, you are creating new content in generative AI. So let's take a look. So the function of predictive AI is designed to analyze the existing data and make predictions. The root word or the golden word here is you are making predictions based on the data, the training data that is given. And these predictions are about the future events or outcome, again, which is based on the data. So remember, when we say data, always remember the quality and quantity of the data is very important. Now, what is the function of generative AI? Generative AI focuses on creating new content, right? Creating new data that resembles the training data, often creating entirely new and original output. So this could be, you're talking about text, you're talking about video, you're talking about some code, right? So you are generating all these kinds of data, right? So normally predictive AI is used for data analysis. Like we said, it often involves statistical methods and machine learning algorithms to identify patterns or trends in historical data. Like you studied that, okay, if you want to look at, if I'm giving several images, if I want to distinguish between a cat and a dog, or we studied about the iris flower, right? You remember the iris flower we studied, and in that we could see whether it is iris setosa, is it iris veriscula. It's all based on the features that were given to it, right? And we also studied about the stock market prediction, right? What would be the stock price for future, right? So this is all based on the data analysis that you're carrying out. But things change in generative AI. In generative AI, the main aim is content creation. You're capable of generating text, images, music, and other forms of media, or even you can say pieces of code. So you can ask generative AI system to write a Python program for you as well. Then we talk about the applications. I think a bit repetitive, but it is normally used in forecasting, like weather forecasting, stock market price prediction, risk assessment, customer behavior prediction, even you can say fraud detection, right? For all this, you would use a predictive AI system. For generative AI, obviously you would be using in art, design, generating synthetic data for training other AI models and creating realistic simulations, right? Because wherever you are generating new content or you're creating new content over there, you would use the generative AI. And yes, it provides insights and recommendations, which helps in decision-making process. So now again, we we had a look into the Netflix recommender model, or even Udemy that we I think studied, where if you purchase one course, it shows why don't you purchase these bundle of courses, because these are from the same instructor and they are actually related to your form of say education or the technology you are working in. So these are the kind of recommender systems that work on predictive AI. With generative AI, it has the ability to produce creative and novel outputs which go beyond the scope of input data. So as I said, if I want to write a poem, or if I want to write an essay, or want to write a letter, so you're just giving few words of input, but the way it creates new content is really amazing. Right? So as the name suggests, predictive and generative. So predictive AI is always reactive in nature. So it's reacting based on the existing data. So it tends to react to the existing data and make predictions about what will happen next, right? Very important. It is reactive. But on the other hand, generative AI is proactive in nature, right? Proactive. So it can proactively create new data points, right? So you are generating your data points rather than just analyzing. So in reactive or predictive AI, you were just analyzing the data points, but here you are actually creating new data points, right? So it's very important what is reactive and what is proactive. And again, if we take examples, again, a bit repetitive, but it can be credit scoring models, demand forecasting in supply chain management, predictive maintenance in manufacturing. These are all good examples for predictive AI. For generative AI, yes, ChatGPT, GPT, which is deep learning model for text, for DALL-E for images, music composition, and AI for generating synthetic data sets, and even for like code generation. So these are all the different examples for generative AI. I think with this lecture, you've got a very good understanding of the differences between predictive AI versus generative AI. Thanks for watching. Most important concepts that we study with generative AI is called LLM. Now, everywhere you will hear the word LLM, but what exactly is LLM? So LLM stands for large language models. As the name suggests, these are really large, right? They are first of all not small models. Here we are talking about multi-millions or billions of parameters on which the model is based, right? And as the name suggests, language, so definitely they are related to NLP, or the natural language processing that we studied, right? So LLMs are sophisticated AI systems that are designed for processing, understanding, and generating human language. That's very important, right? So what it is saying is that, let's say you give some input. So it is able to understand that input. It can process that input, and based on that processing, it can actually generate human language for you. Like we take an example, if you ask the LLM to write a poem or write a story for you. So that is the kind of input you're giving to the model, right? And based on that, it can actually come up with a human language for you. So as the name suggests, large, so the main thing is the scale and complexity. So what it says, as the number of parameters increase, the complexity of the model increases. Now, every time you will hear the word parameters, so we'll go more deep dive into parameters, but first let's understand the scale and complexity. So LLMs are composed of millions or billions of parameters, right? Making them highly complex. Now, the best example we use is for ChatGPT or the OpenAI system, GPT-4, with its vast number of parameters, which can generate human-like text. Now the question comes, but what are these parameters, right? So the best way to understand a parameter is, let's say you are building a house, right? So if you're building a house, what could be the various parameters for a house? It could be the number of rooms in the house, right? It could be the size of the rooms, right? It could be the layout of the house, right? So these all are parameters, right? Now, if we actually translate into an LLM, right, what could be the parameters for LLM? It could be the ability to generate, you can say it can generate different types of text, right? This is one parameter. It can translate text, right? So if you give it in English, it can give you in French, in German. It can create a summary for you. It can create, let's say, a poem. It can create, let's say, a story. It can create a letter, right? So these are just few examples of parameters, right? But here we are talking about billions of parameters. So just think about it. Because of that, there's a huge scale, and that makes the model complex. So they are trained on vast data sets, right? comprising a wide range of internet text. So I think we already studied in GPT-3, GPT-4 that these models are not simply that you are just giving some training data, sample data. No, they are trained on vast amount of data. Like they would be trained on all the articles from Telegraph, all the articles that are there on Wikipedia. So it's example is GPT-4, which is trained on diverse data set, which includes books, websites, and other text, right? So we already studied about it. Now, yes, very important. So you can be asked which are the popular LLMs, right? So this list will keep on growing, but mainly I will keep OpenAI. So from OpenAI, you have GPT-3, GPT-4. So Google came up with Bard, and then it was not very successful, and now they've come up with Gemini. So Gemini is really becoming popular. I believe by the time you'll be working on this lesson, it might actually be available in your mobile phones as well. So Google has got Gemini. Then there is Cohere. So Oracle has got a good tie-up with Cohere. So a lot of so you'll see that in OCI you will get the Cohere models. Then we have Llama, which is actually from Meta or Facebook. So these are some of the popular LLMs. So as the name suggests, it is used for natural language understanding and generation. So pretty simple, right? That's what we said, that it's a design for processing, understanding, and generating. So LLMs can help you to understand and generate human-like language. So I think we've seen examples like you can write essay, poem, or even simulate the conversation. So applications, yes, there can be a lot of applications, like you can create chatbots, you can create content, it can be used for language translation, as I gave you some examples of my parameters, right? So example like GPT-4 powers the advanced chatbots in today's world. So because this is AI, because it is all based on machine learning, these models are constantly learning, right? So as it says, most LLMs use a form of deep learning, right? You now might remember with deep learning, what did we study? We studied neural networks, how the brain, how the human brain works, right? You understood the concept of transformers, right? So it's all based on this. So it says that the learning method is based on deep learning, and it is effective at processing sequences of data, right? So GPT-4 uses transformer architecture, which we already studied. And again, this is continuous learning. It's not that you've given the training data and here you go. No, it is constantly learning from the inputs, the output the person is getting, the prompts that you are giving. So LLMs are designed to continually learn and improve. Very important. That's the key here, right? They are improving over time with more data and user interaction, right? Like GPT-4's performance can improve as it is exposed to more diverse and extensive user interaction. So as more and more users across the world are interacting with GPT-4, then it is getting more mature day by day, right? So the good news is that you can customize. So either you can just use a pre-trained model, or you can customize as well. So some LLMs offer customization option for specific industry needs. Like GPT-4 can be fine-tuned for specific legal analysis or medical advice, right? Let's say you want the language to be really legal language. Like you can actually customize your model to achieve that level of understanding. So here it just shows you, like, these are the kind of inputs you can say. It could be a structured data, it could be text, it could be voice. So all these you basically go so this input goes to the training model. It goes to the so you train your data, or your training you have got your training data, right? You give it to the large language model. It adapts because it's continuously learning. It's continuously learning, and it can produce, you can get information, you can get instruction, you can do object recognition, right? You can do image captioning, you can do something like a Q&A, you can create a quiz, you can do sentiment analysis, like what we studied. Like we will see more examples of it when we study the OCI language, that it can do sentiment analysis in terms of whether it's a positive text, whether it is a negative sentiment, or it is kind of a neutral sentiment. So I think now you've got a good understanding of what an LLM or a large language model is. So thanks for watching. What if I tell you that we are going to understand or study a concept which is really, really important in generative AI? I would say it is the backbone of generative AI and any future systems or any future studies that you'd be doing in generative AI. If I talk about vectors, vector databases, or we'll go and study the concepts like RAG. So it's very important that you understand what is embedding. So embedding is a way of converting the features of an object, like a word, into a vector of real numbers. Now this is quite a theoretical definition if you see. So it says vector is embedding is a way of converting the features of an object. So what you're doing, the main thing is converting the features of an object like a word into a vector. So vector you can think of is nothing but numbers. We will go and understand vectors in more detail, but for now just understand it is nothing but some numbers. Now this is I would say more theoretical, but to understand it properly, I would suggest that if you focus on this diagram, right? So what it says is, let's say we take an example of a cat. Now a cat has several features, or we can try and give a specific numbering scheme or specific numbers can be given based on a certain feature, right? So living being is a feature. Feline means that whether it belongs to a particular family, like tigers, cats, they belong to, or lions, they belong to the same family of animals. Then human is another category or a feature. Gender is another feature. Royalty, verb, or a plural. Like, so for one word, it is saying that it could be put into different categories or different features, right? And based on that, it's actually giving some numbers. So if you see living being, it gives a 0.6. There would be something like an embedding algorithm that it goes through. And for things like royalty, verb, it gives a negative, which it feels that it's a negative. But if you see houses, for houses, it will give, for a plural, it will give a positive number, right? Same way, what it is doing for kitten, right? So it is a living being. It is of the same family. You'll see that it is quite close. This is 0.9. This is 0.8. Then we look at the gender. Again, it could be gender based, whether it's male, female, and other things. So same way what we've done is we've done cat, kitten, dog, houses. And what it says is these are something like you can say it as a 7-dimensional, right? Because we are studying 1, 2, 3, 4, 5, 6, 7 different features. Now it's very difficult to actually work in a 7 dimensions, right? So what it says is then it has to go via a dimensionality reduction, right? So what it does is, with this reduction of the word embeddings from 7D to 2D, so we are going from 7 dimensions to 2 dimensions. So this is a process where a complex, high dimensional data is transformed into a lower dimensional space. So we are going from 7 dimensions to 2 dimensions to make the data easier to visualize and work with while preserving. Very important, guys. You are breaking the data so that it is easier to visualize and work with, but you are preserving as much of the significant information as possible. So you are still kind of preserving much of the significance of that word or those number of different features combined together, right? So this is how it would look like. Now, if you see, now if we look on the right side, so now on the right side of the diagram, you'll see there's a visualization of the word embedding in 2D space after the dimensionality production process. So this shows how the words with similar meanings or relationships are grouped together. Very important. It's not only the words with similar meaning, but words that are related to each other are also grouped together. So in a 2-dimensional space, if you see a cat and a kitten are closely set closely to each other. But if you see a dog is far away from this. Even houses are far away from it, right? So then you have also pairs. So it's another important thing here. It is if you're looking at the features of a man, a woman, a king, or a queen, right? So you'll see a man has a lot of features that are similar to a king. So if you see a living being, yes, it's so the numbers are quite similar, right? If you see human, 0.8, 0.7, right? Then even if you go to gender, it's 0.9, 0.8. So they're very similar, right? So then it is saying you can also have, so one is like cat and a kitten, which like they are closely related to each other. But there could be another relationship where we are saying a man, as a man is related to a woman a king is related to a queen, right? This is the whole beauty of context. When we say the generative AI systems understand the context, it is all about they understand the meaning and the context of that word that you are working on. So how it goes is, here you have a word, right? So the word, from a word we are creating a word embedding, right, which is nothing but a collection of numbers. Then you reduce that, so from 7D you are going to 2D, right? And then it is a visualization of the word embedding in a two-dimensional space. This is how it looks like, right? So let's quickly take a look. So when we talk about embedding, we are transforming the data. So embedding turns complex data like words or pictures into vectors or a list of numbers that a computer can understand. Now we always know from our basics that computers always understand numbers. Now these numbers are what we are talking about here is that you're breaking a complex word, or it could be a picture tomorrow, right? Here I've given an example of simple words like cat, kitten, dog. You could even give the input as a picture. So all it is doing is it is dividing the data or turning the complex data into vectors. Vectors is nothing but again a set of numbers that a computer can understand. And as we just studied here, your purpose is to understand the similarity, right? Similarity. Like as I said, a man is to a woman, a king is to a queen. These are kind of similarities. Or a cat and a kitten are closely related to each other rather than a dog or a house. So they help find similarities between items. For example, in word embedding, similar words are represented by numbers that are close together. Like we took an example of cat and a kitten, right? Very important thing, they help to make big complicated data simpler. As I showed you, like we were talking about 7 dimensions, the 7 different features of a cat, kitten, dog. It helps to break down or make the data smaller in terms of simpler and smaller data, which is easier for computers to understand, right? So that's why you're working on it. And embeddings are used everywhere. Like it helps the computers understand language or recommend things you might like, right? So recommender systems that you are having. So everywhere you will see that embeddings are getting utilized. Now, there are different models or you can say even which are based on different algorithms. So different types of embeddings which are quite popular today are word-to-vec or word-to-vector, which was released by Google. Then you have the GLOVE, which is the global vectors for word representation, and you have also very well-known embedding type, which is BERT. BERT stands for bidirectional encoder representation from transformers, right? So the other thing is that computers can learn to create these embeddings by looking at lots of examples. So from the very beginning, I've told you in machine learning, deep learning, the magic is your data quality and data quantity. And the machine learning algorithms need to learn from data. So the more data you give, the more or better learners your model can become, right? So that is what we are saying. So computers can learn to create these embeddings by looking at lots of examples, which helps them understand and predict new unseen data, right? And yes, some advanced embeddings can even understand the context, because that's anyways I would say the backbone of Gen AI systems, because we learned about bank, right? We said bank of a river and money in the bank. So it's the same word but in a different context or a different meaning, right? So these advanced embeddings can help understand the context, meaning they can tell the difference in the meaning when a word is used in different ways. So as I gave you the example, bank of a river and money in the bank, right? Pretty simple. So again, if I take a very simple example and if I say, where would you place an apple in this two-dimensional space? Obviously, you'll actually look at the features, right? So this is a football, this is say a basketball. So they come under, they are close to each other. They fall in category A. Then we have a category of B, which is of houses. Then we have category where, let's say, which has wheels, like you have a bicycle, you have a car. Now, apple obviously falls in the category of fruits because you have strawberry, you have banana. So the features or the different features that you have for different fruits are similar for apple as well. So it falls under the category of C. So I think with this, you would have got a good understanding of what is an embedding. So very simply, just take embedding is nothing but it is a simple way in which you are converting the features of an object like a word into a vector of real numbers. So in the next video, we will try and understand what are vectors. Thanks for watching. Okay, so in the previous video, we understood what are embeddings, right? Now it's time to take a look at vectors and vector databases, right? So the thing is that a vector database is a type of database which is designed for storing, indexing, and querying the vectors, which are arrays of numbers representing the data in a high dimensional space, right? So now the thing is that if I take you back to what we learned with embeddings, in embeddings we learned that if there was a word like a cat, with cat we were able to get the features of that, and against each feature we were giving a number against it. Now these set of numbers, we call them as vectors. Now all you are doing is you are storing these numbers or set of numbers or array of numbers or embeddings into a database, and this database is known as a vector database. Now you can imagine that if I'm talking about, let's say, Oracle, right? Oracle MS SQL Server, you were storing tables or you were storing the relational data in this. But with vector databases, you are actually storing vectors or embeddings or this array of numbers. Now again, here if you see in this diagram, we are considering different types of inputs. Now it could be a document, right? It could be a picture, it could be a sound, right? It could be a video file. So all you are doing is you are taking it or passing it through the transformer. If it is a text document, you are passing through the NLP transformer. If it is audio, then audio transformer. All it is doing is it is generating a certain set of numbers or embeddings, and these vectors or set of numbers are getting stored in the vector database. So obviously if something is stored in a database, you would be using it for querying, right? And you would be storing it, you would be putting some indexes to make your queries faster, and you'd be making say searches on this data, right? So the purpose is that primarily used for storing embeddings that represent the complex data like images, text, audio in a form that machines can understand and process. Very simple. I think I told you in the previous lecture as well. That was the whole purpose of doing embedding, because you were breaking a complex object into smaller set of objects or sub-objects or features, right? And like we took an example where we saw from 7 dimensions, we were able to go into a 2-dimensional space, like where we talked about the example of a cat. We were having 7 different features. The 7 dimensions were converted into 2 dimensions. And the purpose is simple. You're storing the embeddings that represent the complex data, right? And why we are doing it? We are doing it for similarity searches. Like, is a cat related to a kitten? How close are they related to each other? Or if a man is related to a woman, is a king related to a queen? Like, these are the kind of similarity searches we are talking about, right? So vector databases are optimized for similarity search, which allows quick retrieval of items that are most similar to a given query, right? The examples I gave: cat, kitten, man, woman. And there are several kind of options available, which is you could use the Euclidean distance or the cosine similarity. So there are the different ways in which you can do similarity searches, right? It is just looking at where the vector actually stays in your 2D space. So it is actually widely used in machine learning, artificial intelligence, and recommendation systems. So even recommendation systems, we talked about Netflix a lot. So over there also embeddings, vector databases are being used. Because wherever you have to do a similarity search, right? In a Netflix model, you are actually definitely doing a similarity search where you are looking for what kind of movies do you like to watch, right? It's a kind of a similarity search. It is designed to handle large volumes of data and support scalability and efficient querying in big data applications, because we are kind of breaking a complex object or a big object into smaller, say, a set of numbers, you can call it. That's why it can easily handle large volumes of data. And yes, the vector databases can be integrated with machine learning models, which help to directly store and query the model generated embeddings, right? So the key takeaway is that most of the vector databases that are available today, they can be integrated with your machine learning models. And they do have, they are capable of providing real-time search and retrieval performance. So as we just studied, that you can easily query in real time. So let's say you have loaded some data or you loaded some objects. So in real time, you can perform some searches, and they are quite performant in terms of the retrieval that they do. And they're essential for the interactive applications and services. So just like a normal databases where just you're querying your data from the tables, here you'd be querying your vectors, and the purpose is nothing but to achieve the similarity, right? You're looking to do a similarity search. So with this, we come to the end of vector databases. In the next video, we will try and understand a relation between embeddings and vectors in vector databases. See you in the next video. Thanks for watching. Okay, so a lot of times we've seen that when we introduce concepts like embeddings, vectors, vector databases, folks do normally get confused because they're not able to understand the differences between an embedding, a vector, and a vector database. So that's where I thought it should be good if I give you a breakdown, an actual breakdown of the embeddings, the vector databases, and how they are actually interrelated to each other. I think the best way to understand is that we actually always start with the real data, right? So when you say real world data, the real world data is in the form of text, images, it could be a video, it could be a sound. So this is your real world data. Now, as we studied in embeddings, embedding was nothing but a process that transforms the real world data into numerical numbers or vectors, right? And these embeddings capture the important features of the data, right? So we talked about the cat, kitten example, right? So what you're doing is you're taking the real world data, you are using embedding to create numerical vectors, right? Now, embedding is taking multiple vectors, right? Now, these vectors, they represent your data features. So vectors are nothing but the numerical representation of the data which is created by the embedding process, right? So as we saw again the example of cat, whether it is feline, whether it is related to say which category it belongs to, the male, female, right? So vectors are nothing but the numerical representation of the data which is created by embedding process. And each vector is a list of numbers. So it's always an array of numbers. So it would be an array of numbers like this, right? So each vector is a list of numbers that encodes the data's characteristics. And all you are getting is, you might remember from 7D to 2D, we were able to get it. And all we were getting is, we were getting the features of that object, right? Now, once you have got the vectors, you would have to store the vectors somewhere, right? So normally if I ask you today, where would you store your Oracle tables? You would always, or your normal tables, right? You would be storing your tables in a database. Same way you would be storing your vectors in a vector database. So a vector database is a special kind of database which is designed to store and efficiently retrieve large collection of vectors, and it uses techniques to find the similar vectors quickly, right? So as we studied earlier, it is more about similarity search. So you're doing a similarity search. A man is to a woman, a king is to a queen, right? So you're doing something like a similarity search. Or a cat and a kitten, they are related, right? Or I talk to you about the fruits example. So if you're looking to give them the vector representation, where would an apple come? It will come in the category of fruits. So a vector database is storing and retrieving the vectors, right? It's pretty simple, right? Real world data, you are using embedding, you are creating numerical vectors. Now these multiple vectors are then you are using these vectors, which are actually representing the features of the data, and you are storing these vectors in a database, which is called a vector database. And then obviously here comes the application part. Like, this is all happening at the back end. Obviously, you will have some kind of a front end. So your front end would be your application. So vector databases are used in various applications such as similarity search, where we are finding similar data points. Again, I always tell example of Netflix, where you are using Netflix, where it is using the recommender system, and various other recommendation systems as well, right? So I think with this, you've got a very good understanding of a relationship between embeddings, vectors, vector database. Hello folks, it's time to study a very important concept within AI or generative AI, which is called RAG, right? So it stands for Retriever Augmented Generation, right? Now, if you look at the word, it sounds a bit complex, right? As I always say, always look at the root word and try to break it down. So whoever would have coined this term must have thought about some logic why they kept the term RAG. So let's try and understand. So first of all, the first word says retriever. So retriever means that probably you are fetching something, right? Retriever. So you're retrieving something, right? Now I quickly go to generation. So generation, we all know, okay, you are creating something, right? So that is generation. Now what is augment? So augment is something that where you're doing a value add, right? So you are adding some value. So that's why it becomes retriever augmented generation. So in a way, you can think of it that you are retrieving, fetching some information, and you are actually then, based on the information that you have fetched, you are generating something, right? So let's try and understand by an example. Let's say you were not in the world of AI and you are doing a PhD, right? You are doing a PhD and you've been told to write a paper, right? You have to write a nice paper on a subject, right? So what will you do? You will obviously go to a library, right? You will look at, say, internet. You will browse or you will look at some books, right? So this is like your entire source, right? This becomes your source of information, right? So now you've created your source, and when you have to write the paper, obviously you will combine all these and then come up with a document, or you will come up with a paper, right? Same thing happens in RAG. So what is happening is, if you see here, the user is requesting, or you are putting a question, or you are checking something that actually goes inside the knowledge base. And in terms of what we've learned, we can think of it like a vector database, right? So you can think of it that it is going in a knowledge base or in a vector database, and you are retrieving that text. So this is the retrieval part, right? You are retrieving the query. So that retrieval query comes here, it looks at the knowledge base, the response goes back. Now, when the response goes back, it is getting back from your kind of vector database. Now it becomes a full prompt, or for the moment you can think of it as an input. Now this input is then fed into the LLM, like a ChatGPT, Gemini, right? On basis of this, so you are using the best of both worlds. So you are using the source as your internal data, and then you are using the power of LLM to generate a response for you, right? So this becomes RAG, retriever. You are retrieving the information from your knowledge base. Augmented, you are adding value by using a ChatGPT or LLM and generating a response, right? So that's the beauty of a RAG. Now you might ask, but where will I use RAG, right? So I was actually thinking about it. Think about it that you're a bank, you're an enterprise company, right? Obviously, you will have your data sitting privately within your infrastructure or within your network. You don't want ChatGPT or any other, say, LLM to have information about that. So that is where vector databases come into picture. So your retrievals will happen from your internal source, and you are just using the capabilities of LLM to prepare a nice prompt to give you a proper reply. Right. So looking at the theory of it, RAG uses a retriever, as I said, to find relevant information and a generator to create the response based on that info. I think it's pretty self-explanatory now. So now here we are saying if you are asked for something like what is climate change, right? So the RAG will retrieve the scientific articles. Obviously, the scientific articles will be sitting in your knowledge base, and based on that, you can create a clear, concise explanation. A RAG can improve the response quality. So you'll see that previously maybe the developers might have to code some information that, okay, you're retrieving your information is like this. But here on the fly, you're generating based on the source data, right? You're using the external information and which provides more accurate and detailed answers. Now, again, here we can take an example where a customer support chatbot is using RAG to pull the product details. So you are, let's say, getting all the product details, right, from your internal database to answer the queries accurately. Okay? So it can be applicable in various domains. It is adaptable to different use cases like customer service chatbots, educational tools, where precise information is crucial. So obviously where you need the specific information, probably you can't rely on the data which is sitting inside ChatGPT or OpenAI. So you are saying, no, I want to rely on my company's internal data source, right? So this is where you will use it. And it enhances the contextual awareness, right? So RAGs use the relevant documents, ensures the responses are contextually appropriate. So from the very beginning, we've been talking about context, right? Now this context you are getting from your source documents or in-house environments, but the LLMs have the capability to understand that context. And this is what the beauty of it, money in the bank and bank of a river. It knows the context. So this way it reduces the errors which can be seen in purely generative models. Right, let's try to understand a bit more, because this was more for say easier way how it works, but in reality how it works. So first of all, think about it that you have a data source. Now this data source could be in the form of a doc, it could be an image, it could be a video, right? Now all these are they are passed through an embedder, right? So you can think about it that all my source is passing through an embedding model, which is actually generating some vectors, and these vectors are then kind of stored in a vector DB, right? That's what we studied, right? That is what a vector database is for, right? Now you've stored everything inside the vector DB, right? So this is 1, 2, and now we come to 3. Now let's say the user is now going through its chatbot and requesting some information, or this query is there. Now again, this query is back passed into the embedder to create more vectors, right? So then if you see, we are here from 3. You are requesting a query. Now that query is going via the embedder and it's creating the vectors. So if you see here, number 6, your vectors are again going here. And then what is happening here is then you are kind of doing a semantic search, right? So it's not a select star from MP where MP number is 10. Here you are doing a semantic search to look for the similarities. And based on the data that is fetched, now this data is fetched to a LLM or a large language model or ChatGPT, OpenAI, right? And then you are passing this through the LLM and this becomes your prompt, what we studied previously. So your information that you are retrieving, right? This becomes a kind of a prompt for the LLM to generate. So in this direction it goes and it generates and gives the response back to the user, right? So this is what the workflow is. So user is submitting a query, right? User is submitting a query, right? The query is transformed into vector representation. So query is going into the vector representation via the embedder. It is going into the vector representation. Relevant documents are retrieved. So this is the retrieval component of it. The relevant documents are retrieved from a data source. Now, as I said, it could be a vector database. Based on the similarity, let's say you've got all the information, then you pass it through the LLM, and LLM will utilize both the query and the retrieved document. So it will utilize both so that it understands the context of both the query as well as the retrieved documents and generates a final response. So this is pretty much what a RAG is. I believe now you've got a very good understanding. If tomorrow you are talking to somebody that, hey, it's very important, we need to use RAG in our organization, I believe you can very well explain to them how does it work inside out? Thanks for watching. Okay, so it's time to understand a key concept in the world of generative AI, which is called LangChain. Now I was thinking, like, if I need to describe LangChain, how should I be telling you guys? So I think the best way to understand LangChain is by understanding Lego. So I believe most of you guys would have either played with Lego or your children would have played with Lego. So what exactly does happen in Lego if you think about it? So Lego always comes with some predefined instructions to build specific models. So if you see, these are small bricks that you get with Lego, right? And you always get some instructions as well. So now you can actually use these bricks to create some models. So you can customize your model. You can create this model. You can either create this model or you can create this model, right? So you can use the same bricks to create something entirely originally based on your imagination. So what you want to understand here is that Lego will follow, or when you're following a Lego, you follow the predefined instructions to build specific models or use the same bricks to create something entirely original. So same way, what LangChain does is, LangChain allows you to use pre-built models or modules for common tasks. So you can customize and combine these modules in new ways to create complex language applications which are tailored to the specific needs. So just try to understand in a way that as with Lego, you just join specific modules. Same way in LangChain, you are just joining everything together and reusing it with your large language models, right? So here it clearly says, just as Lego bricks are assembled following a structured guide to create a final model, LangChain integrates various data sources with AI language models. Or if you want to, let's say, integrate multiple LLMs, let's say you want to have a Llama, you want to have, say, ChatGPT, OpenAI. So if you want to combine all those, then you would have to utilize LangChain, right? So what is LangChain? Now the question comes, what is LangChain? LangChain is basically a technology framework. Remember, right? It is a technology framework. Now just imagine, there's a very good example that they give with LangChain is, let's say you want to create a talking robot, right? So you don't have to start from scratch as a company. You just simply follow the LangChain framework to create a talking robot, right? So everything is there. You can use the pre-built modules and you can customize those modules, right? So LangChain is nothing but a technology framework for integrated large language models. Now, when you see this diagram, things will become very clear to you, because if you think about it, like when we spoke about RAG, right? So what if I tell you that if you want to achieve RAG, or the retrieval augmented generation, then it is possible via LangChain, right? So if you see, what are we doing here? We have a data source, or you can call it the external data source, right? And this data is getting converted into embeddings. And these embeddings are further stored into a vector database, right? And now you are using the same vector database to retrieve, and the contents that you actually get back from the vector database, they act as a prompt and are actually sent to the LLM. So what is it? It is nothing but RAG. And all this is possible just by the beauty of LangChain, right? That is what I wanted to explain you. And it is modular and flexible. So it simplifies the process of incorporating sophisticated AI modules or models into various software applications, and the developers can mix and match, right? Again, with Lego, what we used to do, you can mix and match. You can take a piece here, you can take a piece there, and you can tailor it as per your requirements, right? So it is very developer friendly. So it is designed to be accessible for developers, which reduces the complexity which is associated with implementing AI driven conversational agents. Because if LangChain was not there, and if then it would have become really complex for the developers. That's why it is considered to be developer friendly. Now here we'll take a very simple example. It's a basic example that we are taking. right? We are saying a user queries. A user is giving a query like, what is weather like in Chandigarh today, right? Using an app integrated with LangChain. Simple, right? You have got an app which is integrated with LangChain, and probably you are asking a question, what is the weather in Chandigarh today? Obviously, you can't send this question to, say, ChatGPT. ChatGPT won't know it, right? Because as I told you, let's say even GPT-4 is trained till December 2023, right? So how can it tell how is the weather like in Chandigarh today, right? So obviously you have to fall back on your existing data source or private data source, right? So here then LangChain processes the query, right? First of all, this is the query. Then you are processing the query and identifies it needs a weather data, right? So LangChain can understand, hey, you need a weather data. So it means, okay, I need to get it from my external database, right? So it knows that I need to either call API or use the external database to get the weather information. So basically it understands, so LangChain is intelligent, it understands if you're asking for the recent data, I need to look up my data source first, right? Then the data is processed. So the system retrieves the current weather data for Chandigarh from the weather database. So it knows that, okay, I need to get this information from weather database. And let's say the data shows that it's sunny and 40 degrees Celsius. That's it, right? Your, say a database has returned that it is sunny and 40 degrees. That's it. That was the kind of a response you got. Now comes the beauty of LLMs. Here the LLMs or the RAG, or the G part of the RAG is activated, which is the generate response, right? So LangChain uses a language model to generate a natural language response based on the retrieved data, right? So what I want to say here is the data is actually retrieved from your external source, right? Or your private source, you can call it that way, right? It is in-house, right? Now, once you've retrieved the data, you are passing that as a prompt to the large language model to actually create a nice format for, or a user-friendly format for you, which in a way which will deliver the response. So the kind of response you get is, hey, the weather is in Chandigarh today is sunny with a temperature of 40 degrees centigrade, and it could be more as well. And this is kind of delivered to the user through the app. So this is a LangChain enabled app where when the user requested a query, the query went into your database. It could be a vector database, it could be calling an API. So it gets the data. That data is used as to send the prompt to the large language model, and the large language model then generates the response and delivers to the user. So all I wanted to explain with this video was that please remember that if you are studying LangChain, then LangChain is a technology framework which is designed for integrating LLMs or language models into applications very effectively. Thanks for watching. Okay, so I think by now we understood the concept of RAG, which is retrieval augmented generation. We also did some bit of initial understanding of LangChain, right? Now you must be getting really confused between RAG and LangChain. So I thought we should have a video which should describe the role of LangChain in a RAG. So what if I tell you that LangChain is the heart and soul to achieve a real retrieval augmented generation, or RAG? So if you actually see from this diagram, say LangChain is tightly integrated here. So this is our retrieval part, right? Where you're using the enterprise knowledge base, and from there you are retrieving the documents, right? And this is more of the generation part. And again, LangChain is tightly integrated. So if we actually go through the complete workflow, if you see, the first part is document retrieval and ingestion. Obviously, you are first ingesting the data, right? So when you're ingesting your data or when you're retrieving the documents, then again, LangChain is there. So LangChain facilitates. Again, I'm telling you guys, it is a framework. You have to go with this framework if you have to achieve this, right? So a LangChain is helping you to facilitate the retrieval of documents from an enterprise knowledge base, which could be like your set of documents, PDFs and all. Now, let's say once you've retrieved the documents, then there is a concept of processing and embeddings. Now, I won't go into details of embeddings. By now, we all know that if it is a sentence, if it's a say a word, it is always broken down into several vectors, or which is a collection of numbers or an array of numbers, right? So same way, after the documents are retrieved, they are processed through the embedding model to convert the text into vector embeddings, right? So again, that is being done with the help of LangChain. Now, next part is, okay, you got your data, you created your embedding, but now you need to store somewhere. Obviously, you would be storing in a vector database. So again, the LangChain's role is that the document embeddings are stored in a vector database, and this database is used to perform similarity search. Remember, the similarity search is always done between the query. So whatever query you are giving as a user, it gets converted into embedding and vectors, and those are then compared with the embeddings of the document, right? So this way a similarity search is done. Now the next stage is, obviously you've done the similarity search. Now it is about query and enhancing the context preparation. Now the LLM, this is the generation part, comes into picture, where you need to send this as a prompt. So once the relevant documents or embeddings are identified, LangChain helps in preparing the enhanced query context by combining the original user query with the information retrieved. So this is becoming your prompt, right? So this is becoming your prompt, which is the user query plus the data that you extracted, right? So user query plus data that extracted becomes your context. So this way the LLM knows the context. Then you pass it over to the LLM for response creation, right? So LLM will help you to create the response based on the given prompt, right? So here the role of LangChain is to manage the interaction with this LLM to ensure that the input is correctly formatted and the generation process is effectively executed. So in a way, you can think of it that a LangChain is providing you a framework which is giving you an end-to-end integration from user query to getting the response back from an LLM. So with this, I think you've got a good understanding of what is the role of LangChain in a RAG system. Thanks for watching. Okay, so after getting a good understanding of what is LLM, or a large language model, it's time to understand two more terms, or two technologies, I would say. One is called prompt engineering and other is fine-tuning. So it's quite important from generative AI or LLM perspective that you have some understanding around what is prompt engineering and what is fine-tuning, right? Let's take a look. So prompt engineering. First of all, remember prompt, right? Prompt is like an input, right? So it says the practice of crafting inputs to generative AI model to elicit the best possible output, right? So it is saying it's a practice of crafting or practice of creating inputs or prompts, right? Prompts are like inputs. Think about it like inputs to a generative AI model to get the best possible output. So always remember, in Gen AI, we say that if your input is crap, your output would be crap, right? If your input is good, your output would be good. So with prompt engineering, you are actually testing different ways, right? So now there could be one way in which you say, okay, what is an antibiotic? Or give me some details about antibiotic. Or you could specify, one prompt could be you specify some lines about antibiotic and say, is my understanding correct? Yeah. Or you could say, can you just summarize it, right? This is another type of prompt. So these are the different prompts, and by different prompts and by different outputs, your model is actually improving over time, right? So remember, prompt engineering, it's a practice, right? It's a practice or it's a technology by which you create inputs for Gen AI system to give the best possible output, right? So it includes using specific keywords, structured sentences, and including examples to guide the AI. So at the end of the day, you're training your model, right? You are maturing the model. So the various techniques you can use this. You can give specific keywords. You can make structured sentences. Like I gave you an example, like you specify certain sentences for, let's say, antibiotic and say, is my understanding correct? Or you could say, can you summarize it for me, right? So these are the various ways and you can actually train your model. So the purpose is to maximize AI's understanding of the task and to generate more accurate, relevant, and creative responses, right? So it should be that the prompt that you're giving, the AI system should be able to understand, to process, and then generate the human text for you. So that is the complete purpose, right? So the generative AI should be more accurate and it should give you relevant and creative responses. So in terms of adaptability, it requires an understanding of how the AI interprets different prompts and the ability to adjust them based on the desired outcome. So here comes the concept of context, right? We talked about the bank of the river or the river or the money in the bank, right? Bank word is same, but it knows the context, right? So it needs to adapt based on the context of the requirement, right? So the good thing about prompt engineering is it can be utilized by both novice or experts. Like novice, you can say who are not very trained people, like new people, they might use trial and error. So novice guy would definitely use trial and error. So you give some prompt, you get the output, maybe you're not happy, then you work on your prompt and you give another prompt and probably you get good results. So this is more of like trial and error, and a novice or a new guy would actually use or an untrained professional would use this concept. But experts know how to play with the prompts, right? They will give such an accurate prompt or such an accurate input that they get a very accurate and creative output, right? So they may use sophisticated methods to which is based on the understanding of the model. Now, next concept is fine tuning. So if I ask you in general, if you have say background of IT, what is fine tuning? Fine tuning is nothing but you can say you are optimizing the performance, right? Optimize the performance. That's as simple as that. And that's all the concept of fine tuning is, right? So the process of adjusting a pre-trained Gen AI model to better suit the specific tasks or data, right? So you're fine tuning it, you're refining it, you're optimizing the performance of your Gen AI model, right? So this is called fine tuning. So as I always say, data is the key here. So it involves training the AI on a particular data set to refine its response to be more in line with that of the data's characteristics. So again, with data, two things really matter. One is, I always say, the quality of the data and the quantity of the data. So if obviously your quality is crap, you will get output as crap, right? That's where we talk about the large language models and all, because they are trained on huge amounts of data, internet scale of data, right? Large number of books, say websites, Wikipedia. So all this, these are done. So yes, when we talk about fine tuning, it does require more computational resources and technical knowledge. Obviously, you will need because you have to do a lot of things in parallel. You have to generate a lot of your training data is quite huge. So you would need more computational resources and technical knowledge than prompt engineering, right? Customization, it enables the creation of custom AI that can perform better on specialized tasks. So as we studied that there are either pre-trained models or they are custom models. Here we are saying you're actually working on the real customization where you are creating your custom AI, which can perform as per your use case. Remember, fine tuning is not one time. So it is a continuous process, right? You keep on doing it. You keep on improving your model, right? So we will study later that prompt engineering and fine tuning actually go hand in hand. So remember, it's a continuous process. It's not a one-time process, and the models may require periodic updates as they're exposed to new data, right? As you are exposing the model to new data, so obviously the model has to improve over time, right? And yes, we studied about overfitting. Overfitting is nothing but where we say that the model performs well with the training data, but as soon as some new data is given, then it fails to give the right results. So with fine tuning, there is a risk that the model may perform exceptionally well on training data, but fail to generalize on the new set of data or unseen prompts, right? So that's why I'm saying prompt engineering and fine tuning go hand in hand. So if let's say you haven't trained your model on specific prompts, and somebody gives us very specific prompt which the model is not aware of, then it can give you inaccurate results, and which is something you wouldn't want as a data scientist, right? So quite important. Both techniques are crucial for optimizing the performance of Gen AI models in various applications. They are used in tandem, right? So which means they are used together, or both go hand in hand, as I said, hand in hand, right? So fine-tuning, they are often used in tandem. So fine-tuning can provide a better baseline performance. So it says if you're doing fine-tuning, then you are getting a better baseline performance, right? Because as I said, you are optimizing your performance. That's whole concept of fine-tuning. But with prompt engineering, it can optimize the individual interaction, right? With prompt engineering, you are guiding your model to the right kind of output, right? So with prompt engineering, it can optimize the individual interaction. So it is coming to know, or it is getting more knowledge on what kind of different prompts the user can ask, what kind of inputs a user can have. So it's very important that the model is trained on that. So remember, both techniques are important for optimizing the performance, and both work in tandem. So this we come to the end of prompt engineering and fine-tuning. Thanks for watching. In this video, we will discuss $1 million question. Why $1 million question? Just look at how the world is getting crazy about AI. And the backbone of this AI is, in terms of infrastructure, I would say, are the GPUs. Now you just look at the NVIDIA shares. They're just skyrocketing today. Hence, everybody really wants to know what is a GPU. Now, I'm pretty sure everybody who's actually watching this video know about a CPU, and you've been using the CPU for ages now. But why suddenly the GPUs have become so important in our lives? So let's take a look. What is a GPU? So a GPU stands for Graphics Processing Unit. Very important. Now you may think, but hey, we are talking about AI, but this is graphics processing unit. Why? Because when the GPUs were designed, they were actually designed to accelerate the graphics rendering, right? So they were mainly for graphics, for gaming. Some people even used to say it as a gaming processing unit. A lot of people used to say it's a gaming processing unit. So for 3D games, for graphics rendering, this was the whole purpose. Now, the biggest, key area about GPU that you need to be aware of is that it has a highly parallel structure. Now, the biggest difference between a CPU and GPU is, and you look in further videos, is CPUs things are serial, and with GPUs things go parallel, right? Pretty easy. So GPUs have parallel processing architecture, which allows them to process many computations simultaneously, right? So with CPUs, the computation is done in a serial manner, but GPUs are able to break down the same task and run it in parallel. Obviously, you can do more things in less time. So as I said, the GPUs were actually brought for graphics rendering. So what is rendering? So rendering is also known as image synthesis, which is the process of generating a photorealistic or even a non-photorealistic image from a 2D or 3D model by the means of a computer program. So you have got a say a 2D or 3D model, you want to bring it into a more like a photorealistic image. Through the computers, you do that. So originally, as I said, GPUs were designed to render graphics for applications such as video games and 3D animations. At that time, people were not even thinking about AI, right? They just thought that, okay, this is because gaming was really becoming very popular if we go back, say, 10 years down the line, right? So now people started thinking, hey, because of the power of a GPU, I could actually utilize in machine learning and AI. So now the scientists started thinking that why don't we use GPU in the field of AI? So in the field of AI and machine learning, GPUs are instrumental for training complex neural network. Because just think about neural networks, right? As we saw that there are multiple nodes that they are connected to each other. So GPUs with their parallel processing really help in training of these models, right? So because you can handle multiple operations concurrently, hence this parallelism process, and because of thousands of cores running in parallel, really helps the machine learning and AI. And GPUs are more energy efficient. Remember guys, you might think that, oh, there are thousands of processors, so that won't be energy efficient. No, the way GPUs are designed, they are more energy efficient than the traditional CPUs for parallel processing tasks. So you can do parallel processing tasks with CPUs as well, right? But they're not energy efficient. So you can say run a task using multiple cores, but the architecture of GPUs is such that it can break a task into multiple subtasks and do it in parallel. So GPUs offer a better performance per watt ratio, right? Now there are two main types of GPUs. One is integrated. Integrated, as the name suggests, that inside which are built on the same chip. So on the same chip you have the CPU and you have the GPU as well, right? So here you have the CPU and here you have the GPU. So this is more of integrated. And we have the dedicated. Dedicated is that you have dedicated GPUs which are separate cards with their own memory and processing power. So it could be dedicated that you have this GPU and you have the memory and you have the processing power, right? And this obviously offers superior performance. So this is more dedicated and this is more integrated. Integrated means on the same chip. You are having the CPU and you're having the GPU. Now, GPUs are essential for powering virtual reality. So a lot of VR that you would have seen and augmented reality applications. And because again, the thing is speed and performance, right? To create immersive experience. So main thing is parallelism, right? So that's where wherever you see a large amount of data, large amount of graphics that needs to be rendered, you will always see the presence of GPUs. Yes, the technology behind GPU continues to evolve rapidly with constant innovations leading to faster, more efficient and more powerful GPUs suitable for a wide range of applications. It is, I would still say they are early days with GPUs. So right now, if you talk about real companies who are actually making GPUs are NVIDIA, AMD, other companies like Intel, ARM, they are coming up, right? They are coming up with their innovations and all, but the real leader today is NVIDIA for sure. AMD is definitely catching up. So yes, so look at this space. You'll see a lot of investments happening in the world of GPUs. So here what I've done is I've just given you a quick summary of the division or difference. So CPU stands for Central Processing Unit. By now we know all this. GPU stands for Graphics Processing Unit, or as I said, some people used to say it, Gaming Processing Unit. Now with CPUs, normally you say that there are say several cores, like you could say I have 10 cores, 8 cores, 20 cores, even sometimes it goes up to 100, probably not more than that, right? But GPUs, they really start from hundreds, thousands. If you see this, just look at its architecture diagram, right? Multiple cores, so many cores are there, like thousands of cores are there in GPU. And CPU offers low latency. So that is the main benefit of a CPU, because things are done in it does a complex task in a more serial manner. It is low latency, but GPUs give high throughput because of its parallel nature, right? That's the main thing. And it is good for serial processing. As I said, if you have some computation tasks, the CPUs always go one task at a time. So they will work on a task, then will go to the next task and goes on like that. But GPUs are perfect for parallel processing. That's where we are talking about things like graphics, we are talking about 3D games, right? We are talking about machine learning, deep learning, neural networks. Everywhere you can see the GPUs are being utilized. So a CPU quickly processes the tasks that require interactivity. So that's as we have low latency, as I said. So you are looking at more like an OLTP kind of environment, right? Online transaction processing, where you want a quick result, right? So you quickly process the task and give the result back. But GPUs, they break the task into separate tasks to process simultaneously, right? So that's the nature of a GPU. So CPUs, as I said, the traditional programming are written for CPU based execution. So Additional software and additional programming functions will have to be written for you to use GPUs to utilize the parallel execution. So that's quite important point for the devs, because mostly traditional programming was written for CPUs. People were not really concerned about GPUs, but now I think devs need to be aware of it because it requires additional software to convert the CPU functions to GPU functions for parallel execution. So I guess with this, you've got a very good understanding about what is a GPU, and yes, just an image of GPU, how a GPU looks like in real world. And so you can always Google NVIDIA processors and you can see what all different processors they have come up with. In the next video, I will actually give you a difference, a clear demo, which shows a clear difference between CPU and GPU. Thanks for watching. Hello and welcome. So now, actually, I'd like to share a video which was an eye-opener for me. You know, like when I was investigating about GPU, what's the difference between a CPU and a GPU? Because these are the simple thoughts that come to your mind, right? So probably most of us are already aware of what a CPU is, but a lot of people might not be aware of what a GPU is. Anyways, we looked at it in the previous lecture where we compared a CPU to a GPU. So whatever I told you theoretically, what if I actually show you in the form of a demo? Now, this video is actually taken from a video which was uploaded by NVIDIA, and it was uploaded almost 10 years back when they actually introduced GPUs to the whole world. So here you go.
And he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
And 10,
9, 8, 7, 6, 5, 4, 3, 2, 1, go. Boom.
Ladies and gentlemen, science class is now over. Thank you.
Okay, so I believe you enjoyed the video as much as I did. So that's a clear indication of a CPU as compared to a GPU. So a GPU with thousands of cores running in parallel. Thanks for watching, guys.